Assalamualaikum, ladies and gentlemen. This is Dr. Nasir Mahmood Khan, advisor in Wing Science and Technology and the symposium coordinator for today's international symposium. Indeed, it's my upon privilege to start the proceedings of today's international symposium with the permission of chief guest, and yes, thank you very much, sir. Very request for the petition from Holy Quran, please.
أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم الرحمن علم القرآن خلق الإنسان علمه البيان الشمس والقمر بحسبان والنجم والشجر يسجدان والسماء رفعها ووضع الميزان ألا تطغوا في الميزان وأقيموا الوزن بالقسط ولا تخسروا الميزان صدق الله العظيم.
All the guests and participants are requested to rise for national anthem, please. Assalamu alaikum and Bismillah ar-Rahman ar-Rahim. Being a symposium coordinator, it's my humble duty to give an overview and summary of the today's International Symposium. Honorable Chief Guest, Engineer Muhammad Najib Harun Saab, His Excellency Professor Dr. Iqbal Chaudhry Saab, the Coordinator General of Comstech, Excellencies, diplomats, distinguished experts from academia industry, vice chancellors, rectors, ladies and gentlemen, and the participants, especially who are present here and available with us online. Assalamu alaikum and very good morning. It's my privilege to present a brief overview of this international symposium on unlocking the role and potential of sustainable mining and minerals industry for momentous economic growth in developing nations, organized and the auspices of the comstech and aligned with the OIC STI Agenda 2026. Ladies and gentlemen, besides agriculture, mining plays a vital role in economic and industrial development of nations. It provides raw material for various line industry and to the over-increasing demand of industry, especially for the rare and very important minerals. Pakistan is blessed with the metallic and non-metallic mineral resources. Around 52 economic minerals are available across the country. According to the Geological Survey of Pakistan and the report by the Planning Commission, Pakistan holds the world's second largest coal reserves and the fifth largest copper reserves and the fifth largest coal salt reserves are in Pakistan. The newly discovered third coal reserves alone stand at an estimated worth of 180 billion tons. Yet, despite this extraordinary wealth and the mineral sector's contribution to our GDP remains quite low. The primary bottleneck is what has been termed as the resource curse of low-tech, a lack of advanced explorations and mining techniques coupled with poor value addition process. This challenge is not in Pakistan alone. Across the OIC region, from Central Asia and Africa to diversifying economies of Saudi Arabia and Turkey, member states face similar structural gaps. Many nations lack the financial and technical capacity to even properly map, let alone develop their mineral potentials. Why this symposium and why we are now gathering here today? The symposium comes at a highly significant time. Nations around the world are increasingly recognizing the strategic importance of the minerals in shaping economic growth, industry development, energy transitions, and technology advancements. Global demand for critical minerals and rare earth elements is growing rapidly, which presents a unique and time-sensitive opportunity for Pakistan and many OIC member states which has such potential to reposition themselves with the global minerals value chain, moving from traditional extraction towards technology-enabled, sustainable and value-added mineral developments. Comstech's role in this journey is indispensable as a platform for knowledge sharing, technology transfer, and institutional collaborations across 57 member states of the OIC. This symposium also fully aligned with the Pakistan's draft National Mineral Development Policy 2025, which boldly prioritizes local processing over raw mineral exports. Keeping these realities in view, the symposium has been designed as a platform for knowledge sharing, dialogue, and roadmap development by R&D experts, regulators, academia, and industry, and international experts. Over the next 2 days, discussions will be focusing on several critical themes such as advanced explorations, technologies, mineral processing and value additions, critical minerals, digital mining and automations, human resource development and capacity building, environment, health and safety, and technology transfers and collaborations with, among the OIC member states. We are honored to host a diverse global assembly of engineers, scientists, policymakers, and industry leaders from Pakistan, Malaysia, Turkey, China, Germany, and the UK, alongside a large number of registered, expected online participants joining in technical sessions in coming 2 days. Regarding the program structures today, the first technical session will address value optimizations, featuring case studies on third lignite and mechanical salt cutting, Technical session 2, after the lunch break, will focus on critical minerals, rare earth elements, and opportunity in the gemstone sectors. Tomorrow, being the day 2, the technical session 3 will explore engineered surfaces and copper recovery from tailings. Session chairs and moderators with the reportees will be marking structured notes throughout all sessions, capturing key points and gaps, feeding directly into our closing panel discussions, where speakers, stakeholders, and participants will synthesize technical and regulatory findings into a unified, actionable roadmap with their commitment. The panel discussion, as proposed tomorrow, will culminate in agreed commitments to collaborate on capacity building, R&D projects, technology transfer, and institutional partnerships, elevating least developed OIC member states in line with their national priorities under the OIC STI 2026 framework and comstech mandate, with the ultimate aim of building a scientific culture that uses science and technology as a major contributor to socioeconomic development and industrializations. Ladies and gentlemen, the choice before us is very clear. We either become architects of our own resource destiny or we remain exporters of raw materials, while others capture the value that rightfully belongs to the nations, to peoples, and our society. With this brief overview, I wish you all highly productive deliberations and meaningful outcomes over these 2 days. Thank you very much. After. So I would like now to invite our Coordinator General, Professor Dr. Iqbal Chaudhary, who is having a Musbah Peace Upon Prize laureate, Medal Imtiaz, Sara Imtiaz, and Tanga Imtiaz. He is the Coordinator General and the Senior Honorary Advisor at the International Center. Because a lot of audience may be online with us and new audience. We like to talk to. Yeah, thank you, sir. A Senior Honorary Advisor of the International Center for Chemical and Biological Sciences, University of Karachi, and Vice President, Central and South Asia of the World Academy of Sciences. Professor Chaudhary is internationally recognized as a leading scientist in the natural product chemistry. He has made pioneering contributions to the discovery of novel bioactive natural compounds. His research on combating bacterial resistance to antibiotics represents a significant contribution to global health sciences. He has also played a pivotal role in establishing research centers and strengthening scientific capacity in Pakistan, Africa, South and Central Asia. Professor Chaudhary's scientific excellence and contribution to research and capacity building have earned him numerous national and international distinctions. He has authored over 1,530 research publications with more than 51,000 citations, and H-index of 90 and I-index of 1083. His scholarly contribution also include 95 patents, including 64 US patents, 98 books and 40 book chapters published by leading international publishers. More than 110 students have completed their PhD degrees under his supervision.
Thank you very much.
Chaudhary,
أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم السلام عليكم ورحمة الله وبركاته. Good morning, ladies and gentlemen. My very dear brother, Engineer Najib Harun Saab, person par excellence. Today I can have my presentation only on him. His contributions are so numerous that we need to write literally books, not one book, but books. He has been instrumental in advancing engineering sciences in Pakistan. He's a futurist, who think beyond the boundaries of human imagination. He think what this country can be, its potential which can unleash and make this nation a great nation. And so very profoundly I'm grateful to my dear brothers, Ambassador Saleh Muhammad Ahmed Muhammad, the ambassador of a very large country, Sudan. And why I'm saying large country, because you can fit literally three Pakistan in Sudan with this tremendous mineral resources. And then my very dear brother, His Excellency Mansoor Khurram, High Commissioner of Mauritius, which is a smaller country, but so much of natural resources and so much of human resources, as well as this beauty which we call heaven. If you reach Mauritius, they say, welcome to the heaven. And then we have our very dear brother, Ambassador of Turkmenistan, sir. Thank you very much. We have Tajikistan. And we have Ambassador of Egypt, representative of other diplomatic missions. We also have with us a very distinguished panel of experts joining us. Professor Dr. Shukru Talash. Sir, thank you very much, brother. I was in Turkey only a week ago. So, and I know how much Turkey has developed in various sectors, and we're so proud of you. Professor Dr. Nurul An, Program Chairperson, Extraction School of Material and Mineral Sciences, University of Science, Malaysia. Professor Dr. Haryani Labidi, she's an expert, and she also is from Malaysia. Dr. Ku Isra Hani Ishaq. She's a professor, School of Material and Mineral Resources, University of Science, Malaysia. Professor Feng Yang, CEO of Kijali Technologies, China. Dr. Mayo Sichon from a country which I really don't know, UK.
Name of the
First country,
China.
China, of course. So there was a strange country written which is not in the list of United Nations. And then we have several online presenters, Dr. Marcus Nathe, Dr. Zakai Ma, Dr. Khalid Muhammad, Dr. Frederick Crawford, and then we have Professor Dr. Tahir. See, and then rectors of some of the finest institutions in this country and very distinguished guests. Dr. Nasi talked about the available natural resources in this country, and I remember my father used to say that the best natural resource is between the 2 ears. So if you have anything which is more significant than anything underneath, is this brain. And you know, if you look into the context, what is happening and what Nasir presented, this trillion of dollar of resources, according to CESRIC, which is a specialized statistics institution of the Muslim world, there is estimated $46 trillion natural resources, and that doesn't include oil. You know, 70% of the oil resources are in the Muslim countries, 57 of them in 4 continents, 2.1 billion population, 1/4 of humanity, roughly about 46% of the landmass. And, you know, the human resources, natural resources, and then we have this curse, historical curse of colonial time. 95% of the Muslim world was colonized. You know, no other region of the world was colonized to the limit as the Muslim world was colonized. 95% of the OIC region was colonized. And until 1990, when Soviet Union broke, this colonization continued. So from 15th century till the 20th century, we had this tremendous colonial exploitation of our natural resources. So when I travel to Paris, West African and North African are here. When I travel to Holland, Netherlands, when I travel to Belgium, when I travel to UK or to USA, I see the hard work, exploitation of tremendous natural resources which were used untapped. They have just absolutely used it and looted those resources. But what happened even after post-colonial time? It didn't really change much because they left behind a bad governance. They left behind corrupt regime. They left behind looters. And, it's more like a reactionary approach, but this is a truth which nobody can deny. So reminding you that these natural resources would really go, crude oil, raw resources, ores, and all that, will go all the way to the places where they are value added. And we import them in very high cost. What is the reason? Apart from systemic governance issue, there is a major issue of human resources. I think where we can contribute as an institution par excellence of the OIC, the premier institution of OIC responsible of science, technology, higher education, our responsibility to invest our time and efforts on developing human resources, because that is critically important, more critical than natural resources. Singapore has no natural resource. Our sisters are sitting here. South Korea has literally no natural resource. Belts, even countries like Finland and Denmark has no natural resources. Even Japan has very limited natural resources. What makes them different is human resources. So if we need to invest in anything, is human resources. And that too, interdisciplinary, because this unleashing the potential of mineral resources has nothing to do with simple classical mineralogy. It is more of now technologically evolved, developed interdisciplinary field, cross-disciplinary field, where we need to use not only classical engineering discipline, but also data science, GPS, AI, and other technologies. Only then will we be able to benefit from the resources we have. If we don't do that, the exploitation will continue forever. So our emphasis need to be on human resource development. And this is exactly what comstech is doing. This is what our mission is, not only in this particular sector, but also in all sectors. To be health or higher education or water resources and others, human resource is critically important. So if you can really help, kindly constitute networks of experts. Please let us know how can we align these institutions, individuals, and make them capable of using their own natural resources on their destiny. And that is where comstech would like to contribute. I would like to thank you all. I don't want to brag on for a very long period of time. The only message which I would like to give it to you is that my father's message that the best natural resources is between the 2 years remain valid today and forever. Thank you very much. Thank you.
Thank you very much, Dr. Saab, for your very enlightening remarks and signifying the role of mines and mineral sector, potentially not in Pakistan, but also in the OIC regions, and how we can work together and how we can use the mines, the natural resources for 2 years. And if we use these mines, further deposits on the surface, legally we can explore much more precious, wealth for the socio-economic development. Let me introduce today's keynote speaker, Professor Dr. Tahir Khan, for the inaugural sessions. Dr. Tahir Khan is a distinguished material scientist and academic leader with an exceptional international profile. He currently serves as the Vice Chancellor of Ahmedabad University of Science and Technology. With a career spanning leading global institutions, he has held prestigious positions, including the 50th anniversary chair at the University of Bradford, UK, Qatar Petroleum Research Chair in the Materials at Qatar University and Professor at the University of Calgary, Canada, renowned for his contributions to materials engineering, research leadership, and academic excellence. Dr. Khan has played a pivotal role in advancing innovation, industry collaborations, and higher education on a global scale. Ladies and gentlemen, Professor Dr. Tahir Khan, he will be giving us talk. He will talk on the minerals to engineered surface. Dr. Tahir, sir.
Bismillah ar-Rahman ar-Rahim, and thank you so much for the kind introduction. My journey starts very far away from Pakistan. When I moved to Canada, I wasn't prepared for the kind of temperatures. I knew a little bit about Canada, but I didn't realize how cold it got. But I was based in Alberta and in the city of Calgary. And these are just some photographs to give you an idea of what it looked like. We experienced something like minus 35 degrees Celsius with a wind chill of about 10 to 15 degrees Celsius. And the University of Calgary is on the far right. And one of the bridges that crosses between two departments is represented on the left-hand bottom photograph. So it used to be a very severe winter, but again, it was combined with some beautiful landscape. The National Banff Park and Lake Louise are one of the most attractive areas. So being in Canada and experiencing those low temperatures, I also ended up with my research interests in Doha, where I was experiencing plus 40 degrees Celsius. So two very, very extreme conditions. But more importantly, as an academic, one of the wonderful delights we have is we can choose who we want to work with and where we want to work. So our research takes us from place to place throughout the world. And so this area of minerals is very important for us. And until I went to Canada, I didn't realize what a challenge it was for an engineer to work in this particular environment. So I was based in Alberta. And the size of Alberta is such that you can take the United Kingdom from Portsmouth, from the southern part of England, to St. Andrews up in Fife, in Scotland, and you can fit the whole of the UK into the province of Alberta. Alberta has only 2 million people, and the UK has about 65 million people. So Canada is a country which is really growing, and it needs a lot of engineers. When I went to Canada, I didn't realize that the natural resources there, known as the oil sands, in fact, is one of the largest reserves of this particular fuel. So something like 75% of Canada, the whole of Canada, there's about 13 provinces, is actually based in Alberta. So the red areas there show you where the concentration of these oil sands are. And the challenge is that the industry that supports this particular industry of extracting heavy oil from the ground involves a lot of various engaging equipment. So it's an engineering challenge. However, when we're talking about mineral extraction, we're not usually looking at a final product. we're normally concerned with the different extractive methods. So a lot of you who are metallurgists or have a materials background will have heard of pyrometallurgy and hydrometallurgy. And so when we talk about pyrometallurgy, we're looking at using extreme heat, anywhere between 1,000 to 2,000 degrees Celsius, to actually extract these metals. So the examples of these metals are indicated there: iron, copper, cobalt, zinc, chromium. So pyrometallurgical methods are used to extract these particular metals. Lower temperature processes such as hydrometallurgy involve aqueous chemistry. So in other words, leaching methods to extract these metals. And these include things like gold, silver, copper, zinc, nickel, aluminium, lithium, and uranium. So with these two processes, and I'm sure in the next day or so, we're going to be looking at some of these processes, you're always concerned with traditional primary manufacturing methods. So first, from the crust, in the form of an ore, you're extracting the metals. And then these metals have to go through some kind of casting or metal forming processes to produce a product. So there's an extensive amount of industry that's involved in this particular area. So this is the area that's very important to Pakistan. But what if I wanted, as an engineer, to take a shortcut? I want to be able to take something from the Earth's crust and use it as a product very quickly. And this is where my interest came in. When we look at various components that are used in the oil sands industry, and these are photographs from industries that I worked with, such as Statoil Canada, Syncrude Canada, their pumping equipment, their slurry management equipment suffered severe oxidation and erosive wear. So these are very big challenges for an industry that supports any form of extraction, excavation, and processing of these particular materials. So these are just some examples in the oil sands industry that give you these particular challenges. If we look at these examples, this is common to most industries around the world, whether it's agriculture, whether it's food processing, whether it's oil and gas, whether it's sugarcane industry. These particular challenges exist. And what are the ways that we are trying to repair surfaces? What are we doing to increase the wear life of particular components? These processes are known as hard facing. So when I went to Canada, the first thing I did was I visited various companies and I wanted to know, how are they repairing machinery? What are they doing? And this particular process is a very time-consuming, laborious process. What happens is that you use various welding electrodes, and line by line, a typical welding electrode diameter is about 5 millimeters. So you take a welding line and you deposit it across the surface that you are repairing. And the materials that you use are usually known as stellite, and they are combinations of nickel, cobalt, and tungsten carbide. So this particular process is a time-consuming process and can take several hours depending on the size of the part that you are repairing. So, two key points. Geology has given us, over millions of years, very useful materials. We're concerned with extracting these important materials. But what if we were to take these minerals and use spraying methods to engineer surfaces? So engineers, within a few seconds, with the right equipment, can actually use the ore and produce a final product, or at least repair machinery. And this is the interest that I have and what I'm presenting today. So when we are looking at surfaces, we're concerned, first of all, with which minerals there are that we can profitably use and use properly to produce a surface that we can use as an engineered surface. So typical examples, and it's not limited to these three: chromite, which is abundant in Pakistan, in the northern areas; bauxite, which produces aluminium, and rutile, which is titanium dioxide. So these minerals have to be processed, and there's not much that you have to do. We have to use powder methods. So powder methods help to break down the powder, the mineral, down to different sizes. So we talk about micron powders, nano powders, and if we mix these powders, and most of the minerals that we have in the Earth's crust are already a mixture, they're already a composite. So they're usually mixtures of ceramic or oxides and metals. So we talk about cermets and composites. And then the coating method, it can be plasma, it can be high velocity oxo-fuel spraying methods, or detonation gun methods. And these are just 3 examples, but there's quite a few of them. And then at the end, we're always looking at quantifying what performance can we get from our surface. So Vickers hardness number is the very easiest one, and it allows us to see if there's an improvement in the surface hardness. So that determines things like the wear resistance. And then obviously we want to prevent rusting because there are different types of solutions and slurries that we want to process depending on the industry that we're concerned with. So corrosion resistance is important. And then if we're producing any kind of coating, we're interested in the adhesive strength. Does that coating, after we produced it, stay on the surface? So in Canada, and depending on what kind of mineral we have and how we process it, we can produce very fine powders. So my area has been nanostructured coatings. And one of the reasons for this is because the finer the powder, the better the wear properties. And this goes back to theory. When we look at the structure of nanomaterials, there are a lot of improvements that we can see in them, both optical, thermal, mechanical properties. So as an engineer, I was concerned with the mechanical properties. So things like the surface hardness, the wear resistance, whether we can use thinner coatings, because we don't want to add weight to any kind of transport equipment or any kind of machinery that has to be transported. And then the shape and contour or morphology of a surface is important. You need to be able to treat all kinds of shapes and sizes. So the kinds of sprayed coatings that we have available, as I've mentioned, there are quite a few. The one I've preferred is high velocity oxo-fuel spraying. And the reason for that is a bit of the work that was done by Thorpe et al. In 1993. They looked at different kinds of spraying methods. So if we want to spray our minerals onto surfaces, we want to be able to have good control of the temperature. Because if we have different mixtures of minerals, they will have different melting points. So if we have metals, then we have lower melting points. If we have oxides, we're looking at higher melting points. So we need good control of the melting temperature. So if you look at the columns there under temperature, HVOF, high velocity oxo-fuel spraying, gives us a very good flexible temperature, but a lower temperature compared to many of the other processes. One of the other advantages is the impact velocity. The impact velocity determines the adhesive strength. So if we're going to be treating surfaces, we want the coating to stay on the surface of the machine. So it gave us the best hardness and gave us the best impact velocity and the adhesive strength. Oxide content, when we're producing the coating itself, you need to be able to coat it with an atmosphere that is inert. And HVOF allows us to do that as well. So the amount of oxide content is the lowest that we can expect. And that is a defect. It can cause problems in the coating. So for those of you who don't know what thermal spraying involves, this is a schematic to show you the kind of process it is. It's a mixture of oxygen and fuel and powder. The powder is the mineral that we are depositing. And you have a substrate, and the substrate can be any metal. It can be an aluminium, it can be a ceramic, it can be a non-metal as well. Most machinery in agricultural industries, in the oil sands industry, oil and gas industry, food processing are different forms of steel. So the gun itself sprays onto your substrate. And as you can see on the right-hand side, the spray gun can be automated. It can be manually controlled as well. But very large surfaces can be coated very quickly. The coating material, a schematic there on the far left-hand side, shows you there's a composite coating. So the composite means that you've got a mixture of hard material, such as alumina, tungsten carbide, and it can be mixtures of the two, and a metal matrix, which is soft. So this metal matrix is usually a metal. It's a combination of nickel, chromium, or it can be a cobalt, and it acts as the soft material that settles onto the substrate surface. The particles remain embedded in that soft metal matrix. The particles are important, and the size of those particles is very important. The finer they are, the better the mechanical properties. Not that the coarse particle doesn't give us mechanical strength or hardness. It does. But we find scientific work has shown that the finer the particles, the more better the compaction. The powder processing, again, this is a very extensive area. A lot of people have worked onto this. There are many, many ways that you can produce these fine powders. Mechanical alloying is one of them. Ball milling is one of them. Attrita mills are one of them. And depending on the kind of powder that you have, the mineral combinations you have, you can refine them or you can increase the powder particle size. So this is what this particular schematic shows. The parameters, again, these are just listed here for the spraying process, include things like the fuel, in other words, the type of fuel you have. Here we've got propylene and hydrogen, which are the two most common ones used for this particular thermal spraying method. And then the fuel to oxygen ratio is important as well, because it influences things like the temperature and the amount of hard phase that is retained in the coating itself. In this table, we're looking at tungsten carbide. And the amount of porosity that's formed as well is important. I won't delve into explaining each of these, but these are general parameters that are very important. Now, I had the luxury of being in Canada when I was working with these particular minerals. And I worked with a company called Mesocoat, which is based in the USA. And they were able to engineer the powders as well. So in other words, I was working with very fine nanostructured powders, and we were able to encapsulate this sprayable powder with what was known as a duplex coating. Exact processes can be replicated here in Pakistan as well. So it's not that we don't have the techniques to do this. We have them here as well. And so what happens is that you have these examples are of the powder that has been engineered so that we can spray and retain the very fine structure of the powder itself. So the important powder is in the middle of the circle, and then you have a cobalt ductile phase on the outside of each powder. Each of these powders is about 45 to 60 microns in diameter. And these are examples from high-resolution imaging. So on the left side, you can see a microstructured powder where you can actually see the grains or the grains that hold a powder together. And on the right, you can see the duplex coated powder. It's a much finer surface texture as well. And that affects many properties like flowability of the powder during thermal spraying, which again determines things like the efficiency of spraying. This is just another high-resolution image to show you the ductile coating from the surface having been taken away, and inside it you see the very fine, hard ceramic tungsten carbide particles. Now, unfortunately, I couldn't increase the size of this, but what I've done is there's a northern part of Pakistan known as Kohistan. And I have a lot of colleagues and people working in industry, and they supplied me with some of this chromite powder. Now, chromite is a mixture of different types of metals. So the ones I've highlighted in yellow indicate chromium, manganese, iron. So these three can form the soft ductile metal matrix. And the harder particles, things like silica, SiO2, alumina, magnesium oxide, these are harder particles. These are also present in chromite. So even before we've gone to the extent of trying to take metals out of this powder, we can take this chromite and we can put it through the thermal gun and treat surfaces. Now, this is taken from one mountainside. Now, this is where we have a risk assessment. So when you take these minerals from one area of a mountain, it may have different amounts of chromium, different amounts of manganese, and different amounts of iron. And so here we're looking at 22 weight% of chromium. However, for a steel to be stainless, you just need above 5 weight%. So here we've got 22 weight%, and we've got all of the hard phases already present in the coating. So there's huge potential to be able to spray this material without having to process or to extract anything, but pass it through the thermal gun and use it as a final product on surfaces. Has it been done? Well, this is a publication by colleagues here in Pakistan, published in the Journal of Materials Research and Technology in 2023, where they have looked at spraying chromite and getting useful coatings. So it's been done. It needs to be scaled up and used for industrial applications. Just to give you, out of interest, the differences between fine and coarse powders when we spray them. So here you've got two micrographs. They're high-resolution images taken from a scanning electron microscope. And the finer powder produces a much more a uniform and a homogeneous coating. And that's shown on the left-hand image. On the right-hand image, the coarser powders give you, again, not a bad coating, but nonetheless, it's non-uniform. Just to give you an idea of what happens to things like the hardness of the material, the finer the powders that we process and use for thermal spraying, then the hardness increases. So on the y-axis there, you have hardness measured as Vickers hardness number, and you're looking at things like between 1,000 to 1,400 Vickers hardness. That's very high. If you look at the two lines at the bottom, they are of the untreated steel, right at the bottom, and then the carbon manganese hardened steel, which is at about 400 Vickers. So the hardness immediately increases when you use certain types of fine powders. And this increases things like the wear resistance. So things like tribology is important, and this is a graph that shows you what happens with the tribological properties of a surface. And so you improve the wear resistance of your metal. Industry is never satisfied with anything that we do in a lab. So a lot of our research that we do, we first look at it in a lab and we characterize properties. But they always say, please use the ASTM G65 test. And so we have this equipment in our labs, and this is a very severe test. And what it does is it allows us to compare what happens when we have a slurry mixture, abrasive material flowing between your test sample and a rubber wheel. And this is the science behind the actual improvement between fine and coarse particles. More finer particles packed together and actually give us much better properties, something known as debridement. The debridement compared with finer and coarser particles improves. So this is an important parameter that we can measure as well. Just to give you an idea of what happens on the surfaces of your samples, you get these kind of pits forming where you're wearing away the ceramic particles, are wearing away metal surfaces. And these are treated surfaces. And when we look at them again under high resolution, we find that the finer the particles, if it's a nanostructured surface, the pitting that forms is much less, which tells us that there's less fracture occurring. So this is a very tough material as well. So not only do we have high hardness, we have good fracture toughness. Again, we don't need to look at that. And this is just another an image that compares the behavior of a surface that's been treated with fine mineral powders compared with coarse mineral powders. The finer they are, the more plasticity it has in the surface. And this is shown by the nanostructured surface. The grooves show that the material still retains toughness, whereas the microstructure, the coarser particles, show brittle fracture at the surface. So powder processes is very important when you're designing powders for use in this kind of surface method. These are just some examples of parts that can be treated. So large impellers, pump cases, turbines, all can be treated as well. So this is just a summary that the thermal spraying process, HVOF, has huge potential. The fineness of the powders is also very important. The finer they are, the better the properties. And the minerals that we have currently allow us to be able to produce a good surface coating. An image I took with my researchers when I was in Canada, when I was working with various companies there. And then the same research and the ideas we had, we extended it to Doha, where my researchers, the younger people there are the researchers and the colleagues I worked with at a company in Las Rafan in Doha as well. Okay, I'm going to stop there. Thank you.
Thank you very much, Dr. Tahir Irfan Khan, for your wonderful keynote address. Now I would like to, it's my actually privilege and honor to introduce, to briefly going through the profile of a great person and brother of Dr. Iqbal Chaudhry Sahab, Engineer Muhammad Najib Harun. He is the founder of and CEO of the Principal Group with over 45 years of experience in civil engineering and construction industry, graduated from NED, and then a master degree with the distinction from Oregon State, USA. He has served as an elected member of the National Assembly of Pakistan and worked as chairman of Standing Committee for Housing and Works. He remained highest taxpayer among all the parliamentarians for 5 consecutive years. As elected chairman of Pakistani Council, he spearheaded transformative reforms to elevate the professions, to improve the construction industry regulations, got approved price adjustment formula for projects by the government, introduced Engineering Excellence Award, annually capstone projects, funding, showcasing to industry, and launched seed funding for brilliant startups and graduate internship training programs, developed green building codes and rainwater harvesting codes, and prestigious COP28 recognition award. Pakistan also secured 6 years extension for PEC signatory status to the Washington Accord during his tenure. At present, he is accepted as a leadership role of the chairman and National Accreditation Council for the TVET sector in NAVTEC to reform the technical stream of engineering profession, its academic challenges and competence, enabling to produce industry-ready employable graduates with their cross-border recognition and equivalence. Ladies and gentlemen, we should welcome Engineer Najib Harun Sahab, the chief guest of today's seminar.
Bismillahirrahmanirrahim. Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Prayer of Prophet Moses from the Holy Quran. O Allah, expand my chest for me and ease my task for me and untie the knot from my tongue so that people may understand my speech. Excellencies, there are quite a few ambassadors and consul generals out here, delegates on the stage from the OIC member states, academia, a lot of professors and vice chancellors out here. So it's an honor and a privilege to be here today. The introduction that was given by Dr. Nasser, I carried a few caps as a parliamentarian, as a professional first, and the professionals rarely go into politics. But I took upon myself some 30 years back as a young man, when a party at that time was being created, and when I came back from US back in 87, the dream was that we will, change this country, Pakistan, and benefit through all the expertise that Pakistani engineers and professionals and scientists like Dr. Tahir Khan has just introduced himself, who are, giving everything to the rest of the world, and our country is sometimes most deprived. So that ambition, even after now 39 years, is still there, and I keep doing whatever I can. And today's opportunity is very important for me, that I got this responsibility 2 months back of the National Accreditation Council. While I was in the parliament between 2018 and 23, between 21 and 24, it was a top-down phenomena, because at the Pakistan Engineering Council, we were trying to fix things as a regulator for the country to set the direction of the engineering profession. This time it's a bottom-up thing, which means that, the technicians, the technical and, skilled stream is there. So this is a bottom-up approach. There, Pakistan Engineering Council was able to achieve the highest level of, affiliation when we became signatory to the Washington Accord. And all engineers from all universities of Pakistan were recognized as part of that strata. So, because like I keep saying, that Pakistan is disproportionate in so many ways. When I say disproportionate, on the one hand, we are a nuclear state, declared nuclear state, and on the other hand, in the field of education, health, and other infrastructures and other things, industry, exports, we are dependent heavily on imports, so we are struggling. So like the engineers are rightly placed in Pakistan, but then we have to ensure that our technologists and our technicians also, through the Sydney Accord and through the Dublin Accord, so that the whole pyramid stays at the top, professionally, and through that affiliation, that recognition is there. I would also let you know that if you'll go and visit the Pakistan Academy of Engineering, Pakistan, among these Islamic countries, till I last checked, is the only country which is a full member of the International Council of the Academies of Engineering and Technological Sciences. Thanks to Dr. Jamil, we lost him a year back. It was his brainchild. And, and I supported him by creating an endowment fund, because, only the fellows were only PhDs. So on these two counts, we have achieved top down, because our PhDs, professors and academia out there was rightly placed. Now, about today's unlocking the role and potential of sustainable. So we've agreed to at the very outset that it is locked, unfortunately. You have to unlock what is locked. So I agree there, because whatever the family silver or whatever the treasure a nation has, it has to be kept in a lock and key, because maybe the generations can utilize it at a proper point in time. But how the world is changing, how, strategically we are deprived for all the right and wrong reasons. We have been deprived of certain, items which we could have had, like Dr. Taib said, if we could have access locally, because Pakistan is a reasonably large-sized country, and we have, areas where we can find ores. Even in our school days, maybe 50, 55 years back, we learned that we have a treasure there, hidden somewhere. Have we exploited that? Unfortunately not. So I won't go into whatever the reasons might be, but maybe the time has arrived, and Pakistan in the past was, exporting our engineers, our scientists, our technologists, and at the end of the day, even the technicians out there trained were exported to the rest of the world. So the whole world went. Dr. Iqbal, he's been very kind and generous. Whenever I meet him, I feel very proud that he's bringing under the banner of this, all the OIC countries. And because, when people go up, we have to take our other nations and countries simultaneously together. And like at the Pakistan Engineering Council, we have been mentoring Saudi Arabia. We've been mentoring Kenya, Nigeria, and the last that I know, Saudi Arabia and Nigeria have already become provisional members of the Washington Accord. So, when you get out of the hole, we have to give our hand and help each other and combine our resources and strength to do that. So Dr. Iqbal was, of course, about the loot and plunder and the history and and the African states. So exploitation was always there. I wouldn't complain about that. Why? If you look at a single statistics, if you'll Google it, on the North American continent, sir, 8%, I'm rounding the figure, a population of the world lives. 8%. And they utilize 35% resources of the world. For them to stay at the top, they must exploit. 35. Why I say that? But who said it's a fair world? We have to protect our own interests. We have to make our own strategies. We have to develop ourselves. The fraternity, the Pakistani people from academia, from industry, who have gone abroad and have changed their personal lives, made good for themselves, but maybe the country couldn't benefit. So we need to provide something harmonious for them. I'm sure there must be some things that Dr. Tahir came back. All of us come back sometime in our life. So it's time to pay back. So and we need to utilize our best people in this country. About the NAFTAC, the National Accreditation Council, I just got charged about 2 months back. The major motivation that brings me there is that can we become a signatory to the Dublin Accord? So the technicians around, which are by, I would say, millions all over the world, they bring them at par to the rest of the world. Whatever the trainings, what matters is the affiliations, the acceptance of the rest of the world, how the linkages, that matters. And of course, at the Pakistan Engineering Council, during the 3 years that I was there as chairman, I ensured, because I come from the private sector. Why I was a highest taxpayer in the parliament? Because I didn't work for the government. I just worked all my life for the private sector. So we need to bring the resource of the private sector, and we need to ensure that our best minds are put together when we, of course, for technology, for development, for exploration. Of course, we have to go make international contracts and stuff. Again, the best people must negotiate those contracts. People who have established integrity, In the past, we keep hearing about the IPPs and whatever we are paying to them for not producing, and how the country is bleeding profusely. So, why I say the best people and people with integrity from all segments have to negotiate, because technology has to be brought in, utilized, and of course, and technology transfer has to take place also. So all these things need to be done. Now, about today's thing, I once again thank Dr. Iqbal Chaudhry Saab, Dr. Nasser Saab. He was my registrar there at the PC. So I've had the privilege of working with him, and of course his contributions, his integrity, his competence. Normally, engineers are not promoted to grade 22, which is in the bureaucracy, the top grade. And I'm sure that he got promoted there because I worked with him for 3 years. So I knew his capacity, his potential. And I promise you, Dr. Iqbal, that having him on your side, you must exploit this resource. So please do that. So, of course, the expectation from the NAPTAC, is there, that because of the developments, the competency-based training systems have to be put into place. A lot of things have to be fixed. But what I believe, that things have to be fixed top-down. A bottom-up approach sometimes works, but it takes a lifetime to work upwards. So priority areas for skill development, because when a lot of people from Pakistan, skilled workers are working, they're doing a fine job, but they don't have certificates and certifications. And now even the Middle Eastern countries are also looking into this. And the criteria of our accreditation, certification, and and training the workforce has to be fixed. So we'll be working towards that. The most important, Dr. Saab, I see Dr. Fazal also there here from GIK. The industry academia linkage is the most important thing, because whatever is being researched upon, whatever is being created, the end user has to be taken on board, so that they benefit through that. So that we've worked in the past also, and the digitization and future for mining skills. A lot has changed in the world. We have to come at par with that. Youth empowerment, we have to exploit our youth resource. More than 65% people under the age of 30. That is the resource. China had a large population at one point in time. They exploited that resource. Where have they reached? And of course, in energy. Now, about the outcome I would expect from this symposium, my expectation would be that all the distinguished participants from all over the world will hopefully deliberate in these 2 days. And I would request you to maintain unwavering focus on actionable, tangibly, because of course there is a lot of things, and then we need to take out of there tangible and actionable outcomes which can be applied for. And maybe at the end of the symposium, a comprehensive Islamabad declaration. This is an opportunity. A friend from Turkey is there, and Professor Saba is also there. So we would love to see an Islamabad declaration on sustainable minerals development, so that we take on board the government of Pakistan also, and the other governments. I'm sure the ambassadors would communicate to them. So in closing, let us draw inspiration from the timeless ethos that has defined civilization. And time has come that we, the whole nation, recently Pakistan gained a lot of importance internationally, doing something different, trying to bring an end to the war. So this is good time here, and Pakistan must provide a leadership to all the countries which follow, and even the Middle Eastern countries. So together, as a larger nation, as a ummah, maybe we need to protect our interests. We need to combine our resources. We don't need to complain. The rest of the world will do what they need to do. Can we protect ourselves, our interests? Can our people who sit on our side of the table when negotiations take place in matters of debt or whatever international things? So mining and all our minerals is a resource, and it has to be exploited at the right time, and probably, inshallah, the right time has arrived, and I expect, inshallah. Thank you, sir. Thank you very much for.
Thank you very much, sir. Your adding remarks and giving your vision.
Sir, let me announce that we have Excellency, our dear brother, Ambassador of Nigeria is with us. You know, Nigeria is Africa. And the good news is that day before yesterday, World Bank announced that Nigeria is going to be one of the 10th largest economies of the world. And in 4 years, hopefully the 6th largest one.
Thank you very much, sir. And I would like now, going towards closing of the inaugural sessions, I would request Honorable Coordinator General, Dr. Iqbal Chaudhry Sahab, and the Chief Guest to come forward in front of the stage for distribution of mementos. And also, I would like to request international speakers, Dr. Shukru and Dr. Nurulan, please join the Coordinator General in front of the Dr. Ambassadors, maybe please join Dr. Khalid Sahab, join. Yes, thank you very much. And please join all diplomats, international experts. Join Dr. Sahab. May I request the Honorable Coordinator General Sahab to please hand over the memento to the Chief Guest, Engineer Najib Harun Sahab. Thank you very much, sir. The keynote speaker, Dr. Irfan Tahir Sahab, I would like to request to receive his memento from the Coordinator General. I will request Professor Dr. Sukru Talas from Turkey to come and receive his memento from the Coordinator General. Dr. Shukru. Yes. After. You. Professor Dr. Nurul Ain from Malaysia, please receive your memento. Come in the middle. Dr. Hayani Zabedi, also from Malaysia, to please come to receive your moment. We have three Malaysian guest speakers from Malaysia, University of Science, Malaysia, from Penang. Dr. Ku Isira Khani. From Malaysia. Now I'd like to request our Chinese speaker, Mr. Fang Yang, CEO of Kajali Technologies China, to please come and save your moment. If we have second speaker from China, Mr. Mayo. If he's not around, we'll go request Professor Khan Guljadoon, professor from Karakoram International University, to please come and save your memento. May I request the next speaker, Brigadier Sir Dr. Sarfraz Ali Saab, CEO Using, to please come and receive your memento. Professor Dr. Abdul Mateen from Powerquest University from Haripur. Engineer Muhammad Yusuf, CEO YSF Mendels Enterprises, to please also receive your memento. With this, so thank you very much. And we will be having a group photo with speakers, vice chancellors, diplomats, with the chief guest and Dr. Iqbal Chaudhry sir. Please come, and some people can come in forward. It's better, sir, on the stairs. Sir. If you can go outside. Yes. After we will have high tea for all the guests and honorable in the lobby of the comstech. So, Nasir, ma'am, right, Assalamualaikum, and ladies and gentlemen, we are going to start the first technical session. I have requested Professor Tahir Irfan Khan Saab as co-chair and Dr. Fadil Ahmed Khalid Saab as chair, and with you, sir, Dr. Abedi Hayani will joining you as a reporter. So please be here. So try to have more kind of recommendations, key points, so that all these key points will be going to feed into the panel discussions tomorrow, so that we can have a good outcomes. Thank you very much. And with this, all program of the technical session first, up to the chair session and the co-chair.
Very warm welcome for the Johnson. First, thank you very much for joining on this very important international symposium. Also, thank you very warm welcome to all of you. It's a great honor to have co-chair Professor P.A. Khan, Vice Chancellor, University of Science and Technology, Ahmedabad. Thank you very much, and we had this morning's keynote lecture, and we start the first technical session, and we have realized the importance of mineral engineering through materials to interdisciplinary field of science and engineering. And if we look at electronic industry, definitely we see the importance of rare earth to very important plus materials required for engineering and manufacturing. So certainly this technical session would be a great platform for networking and to learn from the level of speakers who are going to talk on very important issues. And the first talk is going to be given by Professor Ayani from USM, Malaysia. It's a great honor to welcome Professor to give the first technical session talk. And I would request Professor to kindly join us first. And it's great honor to welcome you in Pakistan and meet you, sir, and learn from your rich experience in the field of material science and engineering. So I would request Professor Ayani to kindly deliver the keynote lecture. First talk of the technical session. Over to you. And let's please welcome the first speaker.
Assalamu alaikum and very good morning. Still morning now. Thank you so much for our distinguished. Thank you so much to our distinguished chairperson that will be sharing and will be conducting our session this morning. I'm Harian Dr. Haridizaliti from the Science Malaysia. Actually, I'm from School of Materials and Mineral Resources Engineering, which is Science Malaysia. And the title for my presentation is the Environmental Baseline, Integrated Risk Assessment for Leaching, or RSL, is or rare earth element mining operations. So this is a sharing session. I try to be more not on technical, but on the problem that occur currently in not so-called problem, but still not yet find the solution in Malaysia. Okay. So I go straight to the background. Okay. So I'm sure everybody knows REE, rare earth element. So basically, what is REE? It's referred to a group of elements that belong to the genetic series. Okay. So if you include scandium and yttrium, so the REE will become 17 critical element. And then I'm sure everybody knows that doing mining and mineral engineering should know this REE, which is now in demand for the green or sustainable technology. As China obviously is the main or the biggest producer of REE in the world. And then we have Myanmar. And then the third one is Malaysia. We are emerging to contribute to the REE mining or minerals also in the world. Okay? So the REE itself has global demand, and Malaysia itself has the potential to become one of the producer of REE in the world. Okay? But in Malaysia, since we are located in the tropical countries, the equatorial lines, so most of our REE coming from the iron absorption state. or we call it the IEC. So the IEC, how to mine the IEC, we call this ISL, or the in-situ leaching method. In Malaysia, we have a few places or few deposits of IEC, which is in Kelantan, Perak, Terengganu, Kedah, Negeri Sembilan, and this deposit have drive the demand for the in-situ leaching mining method to be carried out in Malaysia. Okay. There are advantages and disadvantages of using ISL leaching. The most prominent advantage is ISL doesn't need for you to remove overburden. It's not it's not an open mining method. It's less invasive compared to open pit mine. But at the same time, the most critical aspect if we are doing the ISL is the groundwater contamination and slope instability. That's the main concern in Malaysia. Currently, we have a pilot plant in Perak, which is doing the ISL, but we are still studying how this ISL can affect the groundwater pollution and also the slope instability in Malaysia. Okay, so that's the knowledge gap in Malaysia. We know the problem, we have the deposit, we know the problem, but we doesn't have yet concrete the SOP or the standardized protocol how to control or balance between the mining of this RE with the environmental problem. It's still in the research stage. We have SOP to do the standard operational to carry out the ISL mining, but it's still just like a brief and not yet technical or detailed. So this project, we need to need for integrated environmental and geotechnical framework. So this is the infographic showing the global demand for the REE. So REE are used by all the sustainable or green technology, the EV car, the wind turbine, the handphone, all the high-end technology used need to have the REE to produce that such technology. So on the left is showing the Venezuela, Malaysia. So Malaysia, and then we have the deposit of the RP deposit in Kedah, Perak, Sembilan, Kelantan, and Terengganu. And this is all the non-RE, the non-radioactive leaching, non-radioactive deposit of RE. Okay, back to the problem statement. So this is the problem statement, the operational dilemma that we have while conducting the ISL. Okay. So the advantage of ISL, obviously it less surface footprint than open pit mine. So in mining, we have two methods. Either we want to go for open pit or we want to go for the underground mining. So in this case of ISL, no need for us to remove all the trees, all the overburden, all the clay material on top. We just leach the chemical into the ground, and then the chemical will react with the RE itself, and then the leaching that contain all the RE will collect back into the surface.
First one. Yeah, you can hold. Yes, this one.
Oh, got problem. Oh, okay. So this is the somehow the simplified versions of the process. So we have this ammonium sulfate, the leaching agent, injected into the soil. So we have all this simple hole drilled in on top of the ground, and then all this the leaching agent will go through the clay layer, solution extract the rare earth ion from deposit, and then all the deposit will collected or will be channeled using underground pipe, and later back to the surface where the solution is clean and the REE compound are concentrated into solid. So this is a very simple method of ISL. So no need for us to do all the removal of the overburden. Very friendly method, but the question is on the groundwater. So how far that we know that the leaching agent will just like focus on the RE layer, not go straight to the bedrock, not go straight to the groundwater or the aquifer system. So that's the one problem. Another one is the leaching agent itself. They will interact with the soil particle, and then it will tend to reduce the cohesion and the friction angle. And then when this happens, you tend to have the slope instability or the failure of the slope. Okay. So back to this advantage. So shallow extraction profile normally for the IAC, the deposit, the layer of the deposit normally just like 5 to between 6 to 10 meters below the surface. It's a very shallow deposit. That's why we can just like drill a very simple hole. There's a PVC pipe, and then you pour your chemical, and then it will interact. So you just like concentrate at the 10 to 15 meter top layer of the deposit. Okay. And this is the type of the IAC deposit that we have in Malaysia, thorium and then uranium, and then efficient ammonium sulfate injection. So if we use ammonium sulfate, it will effectively leach all the REE, and then finally we can have the deposit of the concentrated of the REE itself. At the same time, so we have not severe, but still unknown geotechnical property alteration still going on research. Unmet chemical transport in groundwater. So we doesn't know how far the leaching agent or the ammonium sulfate will travel in the ground. Is it like how much? Is it 100% that the 1 liter of chemical inject will also 1 liter of chemical out of the deposit? So yet to study on the aspect. And then the destabilization, and slope failure risk. Okay. So this is a very simple table actually. I always focus on the groundwater and the geotechnical instability here in this case study. So we have here the groundwater behavior. So this is what we expect the ideal operation to be carried out in the ground. So we know where the leaching contains, and then highly predictable fluid recovery within localized zone. This is what we hope for the operation to be carried out. So we know exactly where the leaching agent or where the chemical in the ground. But the reality is we doesn't know unknown flow trajectories, severe risk of ammonium sulfate and contamination beyond the leaching post. So obviously, when we have chemical or water in the ground, it tends to travel far from the source. So that still we need to model, we need to simulate and look how far the leaching agent go, travel, maybe tend to also pollute the surface water, the river surface water. In the case of geotechnical stability, so we have the soil mechanic and shear strength remain stable post-injection. This is what we want, but we have this reality of unquantified risk catastrophic failure due to rapidly changing mechanical soil properties. So the cohesion tend to reduce, the friction angle also tend to reduce, which is obviously it can tend to cause to the failure of the slope. Okay. At the same time, we have this protocol of the SOP problem, not problem, but not so mature enough. So not yet standard, we hope to have standardized risk prediction model built on hyperlocal baseline, but the reality is not total, but in progress of the integrated baseline and lacking actionable detailed existing in SOP simulation. So this is what what we hope in our project that we want to carry out. So actually we can divide it to 3 phases. So the first is the establishment. So this is more the baseline study, the baseline study. So we collect all the geology, the hydrogeology, the geochemistry, and then all the environment of the ground before the ISL carried out. So this is the baseline study. So once we have the data, we tend to, after that we will to simulate the condition of the ground. So we try to simulate the groundwater flow and then complex load stability in targeted leaching areas. So this is what we do. So we have the baseline, which is prior the mining carried out. And then we also do simulation on during the mining carried out and after the mining carried out. And then once we done with the simulation, we develop an integrated 2D and 3D hydrogeological and geotechnical risk assessment model. So this is where we get all our slope stability model, and also we have the groundwater model here. Okay. This is actually one of the projects that we carry out with industry. So industry because RE is a booming industry, booming mining in Indonesia. So lots of industries are interested to know details. So the industry came to us, and also it's a collaboration with industry on this project. So this is a summarize on the problem statement. Okay. So problem statement. The groundwater contamination due to unlimited understanding on leaching, chemical transport, geotechnical risk due to change in physical and mechanical properties of soil, plus incomplete limited environmental baseline and lacking in detail of SOP. So this is the question of research that we want to solve. What is the behavior of groundwater flow under ISL? So how the ISL activities influence slope stability, and what is the critical baseline parameters for risk mitigation framework? Then we have all these 3 objectives to simulate the data and establish. Okay. And this is a simple flow chart. What we have done, and hopefully we're going to, because this is one area in Kelantan. So the plan is for us to do the same methodology, but different part of Malaysia. But the challenge is in this project, you need to find the real site. So that's the problem gap, because you need to have the government approval, the industry approval. So you cannot carry out this research in the lab, but you have to do it in the real site. So this is one of the sites that we carry out in Kelantan. So we did the fieldwork, we collect soil and sample. So we did the guideline drilling for soil sample. And then we test the physical and chemical properties of the soil. So this is essentially to determine the soil stability. And then we also did the borehole drilling. So analysis on surface and groundwater flow, and then we simulate the surface and groundwater flow, and then we using the mode flow to finally to have the model of how the groundwater flow in the ground. Okay. And then for the water sampling, this is more on surface water. So we collected a sample or water sample at 3 ponds near the area of study. And also we collect sample at the small river near the hill, actually the study area. So this is all the parameter we use for to check the quality of the water, the OD, the TSS and everything. Okay. This is really the same thing, but just the infographic. Mode flow to predict the groundwater, and then we have rock science. It's a software that can be used to simulate the slope instability, and then these two info will put together, and finally we can propose the SOP or the guidelines based on the study carried out. This is more on the soil stability. So there are basically we for this research we did our lab test, but at the same time we also review other people's research. So we combined these two data, and then we found out that for the mechanical properties of the soil, in terms of cohesion, there is a reduction of 60% to 78% of cohesion property. So what is cohesion? Cohesion represents bonding force between particles. So ion exchange reaction breaks down this bond, causing the soil to lose much of its inverse strength. So soil become more sustainable to deformation and failure. So the lower the cohesion value, the less stable the ground. So in this case of ISL, the ISL itself reduce the cohesion of the soil between 60% to 78%. This is from the combination data coming from our lab itself, our own data, plus with the review that we found in the journal. Another mechanical properties of soil that we studied is internal friction angle. But compared to cohesion, the internal friction angle just reduced more or less than 10% reductions, not so severe compared to cohesion. But the friction angle also reflect resistance generated by the particle interlocking and friction. So the smaller the friction angle, the less stable the ground. So we want big numbers of friction angle. Also, we want big number of cohesion value. So the bigger the number, the stable the ground. Same with the liquid limit and plastic limit. So also drop 60% and plastic limit drop 70%. Okay? So less value or less number of liquid limit and plastic limit, the material become less cohesive and more brittle. More brittle means more fragile or more or tend to break, become fragmentation. So this is somehow a proven theory saying that the leaching agent reduce the mechanical properties of the soil, which is the result of it, the soil become unstable or tend to fail after the injection of the chemical in the ground. So this is just a infographic also. So here we have the factor of technique. So in the case of slope stability, we want our F4S to be more than 1. So in this case of ISL in our study, it is proven that once you simulate the condition of the ground before and after the leaching, the F4S dropping of cohesion and rising of pore water pressure reduce the F4S, which is you tend to have failure. So failure, if for the stability of the ground, you have to make sure that your FOS is more than 1. Yeah. So factor of safety equal 1, indicating imminent failure. So this is another also a summary. So we have the aspect of study in chemical structure, hydraulic and mechanical. So in the mechanism of the chemical, the ion exchange happening between the leaching agent and the soil particle, which is instructions of interparticle forces, which is we need in order to prevent this to happen, we need to have a transition of much better leaching agent. Maybe we need to have more sustainable and green leaching agent compared to aluminium sulfate. Okay. In the case of structure area, so the soil particle in the ground, when we leach our chemical agent, the chemical agent tend to bring all the fine particle together. So it calls to the stratification and weak interfacial shear plan. So what we can do is we are doing the subsurface mapping to look how the particle react from the original place of injection into the area of flowings of the chemical. And then hydraulic is more on the flow of the agent. So we tend to, when the fine particles are migrated, we tend to have this pore clogging of the soil particle. So we have the loss of metallic suction and rising pore pressure. So what we need to do is we need to do the stage injection, or maybe we need to do set injection and enhance the drainage. So no need to pour the chemical continuously, but stages of injection of chemical. And at the same time, we have to have the pipe that enhance the drainage of the chemical in the ground. So the chemical not stay in the ground long, but it just like flow, reactions of the chemical, inject, and then flow up into the surface. And the chemical, like I said before, we have the 60 to 70% cohesion loss. So what's the result of it? Transition from strain style hardening to strain velocity. So what we propose to have is maybe we can have the plantations of trees, but the one is a lot more on the long term interventions. Yeah. This is a groundwater flow. This is very simple, but yeah, I'm using Gemini, so you tend to be more like a very efficient and very complex. But it's a very simple model using mode flow. So you have the conceptual model where you put all the geological informations, and then you from the geological information you simulate the flow. And then after that, once the simulation done, you can have the predictions of the transport, and then the contamination to contain the transition of the flow. This is the geotechnical investigation, the step. We have mapping, geophysics, drilling, lab testing, and monitoring well. So this is all the method that we carry out to obtain our data. So this is the mitigation. So if you have the forward temperature, we put piezometer. If we have the slope gradient, we put piezometer. If we have the groundwater migration, we put the monitoring well. And this is the where our research impact. So we projected that our research will impact industry, the government and the agency, and also the academia and the society. So this is all the list of the impacted research. Then so the expected deliveries from our research. Okay. Okay, so we have the SOP done, and then we can have the IP, commercial potential, also the academic stuff. Okay, so just some figure to show economic ambition required environmental certainty by proving integrated geotechnical and hydrogeological framework. We bridge the gap between Malaysia rare earth potential and safe, sustainable operations. So this is the conclusion. So not only that we need to have high recovery of REE, but at the same time we need to look also at the geotechnical and the hydraulic aspect. Means the environmental aspect. So obviously we want to have a good recovery in REE, but at the same time we also need to look at the environment. Thank you.
Thank you very much, the BB, for excellent talk on situ leaching and geotechnical risk and important elements that you have highlighted in the study. Open for good questions. Yes, sir.
Hello, I'm from Balkan Mineral Development Corporation. By profession, I'm a geologist. So, can we apply this method on copper deposits? In situ mine method, this method, same method can be applied on copper deposits because you worked on rare earth elements. Do you understand?
You means that you want to apply the same method of RSL into the copper mining.
Yeah.
Not but so far, from what I know, we can also apply the same method into the copper mining method now. The copper mining.
I just want to understand. I just want to understand. In situ mine method is applicable on copper deposits.
Yes.
Okay, and what's the recovery percentage in RE, rare earth taxes?
Because now we have in Perak we have in Malaysia we have the pilot line. But it also depends on the deposit. Because like now.
Yeah, there are thousands of deposits in nature. Do you have any idea what is the recovery percentage in this method for RE, rare earth element? Okay, because I think you focused on environmental aspect.
Yeah. So I don't know how to.
Yes, question.
Thank you very much. I'm Dr. Sakib Nasir from Pakistan Science Foundation. Very nice presentation. I have a question about we have very good resources of coal in Pakistan. Coal, COL. So coal is very rich in REs, rare earth elements, and we have a brown coal quality in Pakistan, especially, and that is easy to handle with the leaching process. So, what's your opinion that the process is viable for coal if we are recovering the rare earth elements from the coal deposits by using this process?
Because I'm more on the environment. But actually, we have the time, maybe we can.
The other point is that leaching is a very slow and economically inviable process. I mean, economically it is not justified. What is the product yield in your process? I mean, what is the actual economical viability of your process?
Also, I don't know because this is not within my scope of. I'm more looking on the geotechnical aspect.
Okay.
Maybe my Dr. Ain can answer.
Thank you. Thank you very much. Thank you.
Yeah, I think.
Actually, for copper, I said it's not a new method. It's actually a very old method. It's been used for copper gold for the low grade deposit. So it can be used as a for copper.
Yes.
It's usually used for the low grade. And normally, the recovery is more than 90%.
Sorry?
90%.
80%. 90%.
It's much even 90% control. And for the questions. For coal, yes, we can do leaching, but it's not easy to leaching. It's a different types of leaching method.
Absolutely.
Yeah,
absolutely
because
different.
we also work on the byproduct steady for the extraction of RE and other metals. Yeah.
Sounds- Thank you.
Thank you. What have you also tried in your simulation? The AI and large language models simulate process or your technical hazards like GIS software that are available.
For instance, for example, to flow, we are using a flow. But for and then for the stability, we are using rock science. It's a commercial software. Workflow is actually based in USGS. So how we can get that workflow device it, so it's under USGS software. But for the rock science, still it's also commercial. In comparison,
You have also linked up with the SDGs, 11, 12.
yes, yes.
Yeah. So that's a great, I think, achievement in terms of sustainability and recovery and making sure the hazards are controlled. So let's please thank our speaker. Now request my co-chair, Professor Khan, to introduce the next speaker.
Okay, the next speaker is Dr. Mohammed Bilal. He's a process engineer at Rico Deep Mining Company. And the title is The Challenges and Prospects of Recovering Copper Sulfides from Tailings. Just wanted to remind everybody, just keep within your 20 minutes of presentation, please. Thank you.
Assalamu alaikum everyone. My name is Mohammed Bilal. I am senior process engineer at Recodic Mining Company. The topic today I'm going to present is the challenges and prospects of recovering copper sulfides from tailings. So if we see the copper and demand and supply, this graph tells us an important story. So the dark green area represents current and probable copper production, while the line tracking upwards represents primary demand. If we see that what happens after 2025, the gap between the two begins to widen by 2030, and the projected shortfall is estimated at approximately 6 million tons per annum. So this is not a minor discrepancy, this is a structural deficit, and the world demand for copper is being driven by the green energy transition, electric vehicles, grid expansion, and renewable energy infrastructure. And at the same time, the discovery of new high-grade ore copper deposit is declining, and the existing mines are processing lower grade ores with lower recoveries. So while the copper demand in conventional applications will increase by only 0.5%, so there will be significant growth from various green energy sectors. This includes 11% increase in demand from EVs and chargers, and 19% growth from grid expansion, and a 7% increase from renewable energy technologies. And the transition to a clean energy economy is not possible without copper, and we cannot mine our way out of this shortage fast enough. This is why recovering copper from existing tailings is not just an engineering exercise, it's a strategic imperative for sustainable development. Now I'll just explain how the copper is being mined and processed. So for copper sulfides, the conventional way is that they are being mined using underground or surface mining techniques, and then they are subjected to crushing and grinding and then flotation, and the concentrate goes to smelter and then refinery, and the tailings goes to tailing dams. However, the problem is that a significant amount of copper is lost into tailings in this flotation process. If we see the data of some big concentrators across the world, we see that around 10 to 20% of copper is lost into tailings, having a grade of 0.04 to almost 0.12%. If tailings, these can be considered as future deposits. So the tailing dams, we can just subject them to again a separation technique. Here I'm showing the flotation, and we can recover copper, and the tailings from that process can be stored into the new storage tailing facility. And the tailings, they don't require any mining to exploit copper. We can just directly process them, and the tailings can be considered future deposits subjected to development of an efficient separation technique. So how tailing loss occurs and copper is recovered. So why tailing loss occurs? That's the first question that comes in our mind. And how can we recover copper from tailings? So why tailing loss occurs? If I just recall the method, as I mentioned in my previous slide, that copper sulfides, they are subjected to grinding, flotation, and then we have the product concentrate goes to smelter and refinery, and the tailings are subjected to tailing dams. So the first stage is grinding. So when the ore particles or ore is subjected to grinding, we have different products. Highly liberated copper mineral particles, which is desirable as a process engineer, and then we have poor liberation, in which copper is not liberated from gangue, and then we have middlings, in which it's moderately liberated particles, still not good enough. And then we have liberated fine mineral particles, but very fine, and liberated gangue mineral particles, but also very fine because of ultra fine grinding. So how the flotation works in flotation cell, if there is a flotation cell having an agitator. So the copper mineral particles are hydrophobic in nature. Hydrophobic means they are water repellent. They don't, if there is any bubble or something, they will just try to escape the water. And the gangue mineral, or which is silica, dioxide, quartz, they are hydrophilic in nature, water lovers. So when the air is introduced into the flotation cell, air bubbles are generated, and the copper mineral particles are collided and attached to the surface of these bubbles and are carried to the surface, collected as a froth product. And the silica, they don't attach to the air bubbles, they are hydrophilic in nature, they remain in the suspension and are collected as a tailing product. So the tailing loss, particle size has an effect on tailing loss. If we have liberated but coarse particles, so what happens, the particle is coming downwards in the streamline, following that, and the bubble is rising. So the particle collides first with air bubble, and then it attaches. On the other hand, if we have liberated but fine mineral particles, what happens? The fine mineral particles, due to their low mass, their collision efficiency is very less with air bubble. They just follow the fluid streamline, and the collision efficiency is very low. Then we have middlings, unliberated particles or poorly liberated particles. So the particle, even if it is large enough but not liberated, so what happens, it collides with air bubbles, but obviously the surface area is not exposed enough, so after collision it does not attach, and however it detaches. So that's why the tailing loss occurs. And how can we recover copper from tailings? So the tailings, they contain either fine liberated particles, which are very fine, and they have low collision probability with air bubble, and they are very difficult to recover. On the other hand, they also contain coarse but unliberated or middling particles, so they need further grinding, which will produce further fine particles. And as I discussed in my previous slides, the fine particles, they are very difficult to be recovered using conventional flotation techniques. So the flotation probability, PF, if we see, so this is directly proportional with the collision probability and attachment. And 1 minus PD, which is the detachment probability. Considering the particle is hydrophobic enough, so the attachment probability is considered as 1 and the detachment probability is considered as 0. So then the collision probability is directly proportional to flotation probability. So if the particle collides with air bubble, provided that the surface area is exposed enough, so as we are assuming that attachment probability is 100%. Also, we are also obviously using some reagents to increase the hydrophobicity of the minerals. So we assume this is 100% and the detachment is 0%. So the collision probability is the main parameter which influences the flotation probability. So the collision probability, particle bubble collision probability, so is given by this equation. According to this equation, so either we have to decrease the bubble size in order to maintain the desired particle size to bubble size collision efficiency. So the desired size ratio also needs to be maintained. So then we have to decrease the bubble size, diameter, or increase the particle size. So there are different methods to improve the fine particles recovery in flotation, increasing particle size or decreasing bubble size. So the increasing particle size includes oil agglomeration, shear flocculation, carrier flotation, and the decreasing bubble size includes micro bubble flotation and nano bubbles flotation. So the oil agglomeration and shear flocculation. So the shear flocculation, the name suggests that we use a high intensity conditioning to overcome the energy barriers to make the particle collide. So the agglomerate size is large enough. And in the oil agglomeration, oil is used as a bridging liquid to bind the particles. So the key parameters in the oil agglomeration are the dosage and type of oil, the agitation strength, and also the hydrophobicity of the minerals. Carrier flotation, on the other hand, in the carrier flotation, we introduce the large coarse carrier particles together with the fine particles. So when we agitate the coarse and fine particles together, due to the hydrophobic force between the coarse carrier particles and fine particles, the fine particles are attached to the surface of coarse carrier particles, so the large agglomerate sizes form, and then together with the coarse carrier particles, the fine particles are carried to the surface as a froth product. So if we consider the tailings, which are low grade deposits, or the also low grade ore deposits, maybe these oil agglomeration and shear flocculation techniques are not may not be suitable, because in the high grade ore the specific mineral numbers is large, so when they collide with each other, the larger agglomerate is formed. On the other hand, as I mentioned, that in the tailings, the low grade deposits, the number of specific minerals is not high enough. So even though if they collide with each other and form an agglomerate that is not large enough to make that difference in the particle size. So it requires large amount of specific minerals, these techniques, oil agglomeration and shear flocculation, and also they may not be suitable for copper recovery from tailings or low-grade deposits. And on the other hand, I prefer or I suggest that carrier flotation may be suitable. Why to choose carrier flotation technique? Because in the carrier flotation technique, if we see when the particles are fine particles are collided with coarse carrier particles and they are attached to the surface of coarse carrier particles, so in this agglomerate size, the carrier size itself determines the agglomerate size. So it does not require the high number or large number of specific minerals. So the carrier size determines the agglomerate size and is suitable for low grade deposit and tailings, the carrier flotation technique. Then the decreasing bubble size flotation techniques includes micro bubble and nano bubble flotation. So micro bubble flotation, uh, we produce in this technique significantly smaller than conventional bubbles. The bubble size is 10 to 100 micron. So smaller the bubble size, higher the collision probability with fine particles, and dissolved air flotation and venturi based generators or spargers are used for generation of these micro bubbles. They are very good in improving the fine particles recovery, but the limitation is that the carrying capacity is very low and there is a potential for entrainment of gangue particles, means the gangue particles can also be recovered using these techniques. And these microbubble flotation techniques is often used in column flotation circuits in the cleaner stage or the scavenger stages. In the nanobubble flotation, nanobubbles are also called ultrafine bubbles, as these are gas cavities with a diameter of less than 1 micron, and the nanobubbles are adsorbed on mineral particles when they are pre-treated with them, forming nanobubble particle aggregates and thus increasing the parent particle size and improving the collusion efficiency. Nanobubbles are produced by different methods such as hydrodynamic cavitation gas, oversaturation, power ultrasound, electrolysis, chemical reaction, solvent extraction, temperature exchange, and membrane modules. These are some different methods, and nanobubbles, they promote the agglomeration of ultrafine particles, increasing the effective particle size, which is required for increasing the collusion probability. And but the challenge remains that the scale up from laboratory to industrial application and also the optimal nanobubble generation conditions are ore specific. As I discussed in my previous slides, there are different methods to generate these nanobubbles. So there are also some advanced flotation cells for tailing reprocessing. Hydrofloat, this is a device or cell. These are used for, as these are fluidized bed flotation techniques. They can be extended to fine particles, but they are very helpful in recovering the coarse particles, which are unliberated particles. As I mentioned, that the tailings also contained larger middling particles. They are large enough, but they are not their surface area is not being exposed enough. But hydrofloat, using hydrofloat, we can improve their recovery, and they are used in the scavenger scheme. Then the Jameson cells, these are high intensity downcomer contacting cells. They are efficient for recovering fine particles. They have a compact design. And then we have reflux flotation cells. They use a combined flotation technique with gravity separation to improve the copper sulfides or any desired mineral recovery. So if we compare these techniques, the carrier flotation is maybe suitable or is suitable for carrier for low grade ores and tailings. But the problem is, if there is no autogeneous carrier flotation technique, then if you're using another type of carrier, then the grade dilution becomes a problem. So the post flotation separation is then desired to improve the grade. Oil agglomeration, oil is used as a bridging liquid, is suitable for high grade ores, not suitable for low grade tailings. Then the shear flocculation, we use high intensity conditioning, so which requires more energy. So this is energy intensive process. And also, as same as oil agglomeration technique, it is dependent on the number of mineral particles present in the ore. If it is high grade ore, it is suitable. If it is low grade ore, it is not suitable. On the nanobubble and microbubble flotation techniques, which are decreasing the bubble size techniques, they are good in recovering fine particles, but there is an entrainment effect and there are lower carrying capacity. Hydrofloat, mentioned earlier, very good in recovering coarse, poorly liberated particles, not for fines. And on the other hand, then the Jameson cells, they are high intensity downcomer contacting cells, very good for recovering fine particles, and they are used in the cleaner stage of flotation circuits. So the challenges and outlook is obviously the first is the mineralogy is the most fundamental, uh, because the tailings, they are not uniform. They contain weathered, oxidized sulfides whose surface chemistry has been changed significantly from the original ore because of the time passed. Because what works in the laboratory on the fresh tailings may behave differently on a 10 or 20-year-old tailing dam. And then scale up remains the critical bottleneck because most of the techniques I have described, particularly nanobubble flotation, are proven at bench and pilot scale, but industrial scale implementation is still limited and reagent optimization is also non-trivial. Tailings recovery requires careful balance, maximizing copper recovery while minimizing the entrainment of gangue minerals that would dilute the concentrate grade, or we can say the selectivity, to balance the selectivity. And finally, the economic viability is the ultimate arbiter. The feasibility of any tailings reprocessing project is governed by the copper price at the time of development. As the copper price rise, driven by exactly the demand signals I shared on the slide 2, I guess, more tailing deposit will cross the economic threshold. So that's all from my side, and thank you for your attention. And if you have any question, please feel free to ask. Thank you.
Assalamualaikum, Dr. Bilal. Uh, can you tell us that this carrier flotation technique is a very recent technique in flotation? Is it possible someone has used this technique in Pakistan?
Thank you, Doctor, for your question. Basically, this technique, like carrier flotation, if we use like the same copper as a coarse particle as a carrier, so somehow this autogeneous carrier flotation is already occurring inside a flotation cell because we have a size distribution curve. So obviously there are fine and coarse particle together. So this hydrophobic interaction occurs, or you can say the effect of this carrier flotation is autogeneously occurring. But however, on the cleaner side, if we are losing some fine particles, so we can redirect the fine streams to a suitable coarse stream inside this flotation circuit, and using the existing circuits, so we can make somehow this carrier flotation work. But the problem is, like, if in the future the ore is depleting, so the mineralogy is getting more complex, the grain size is becoming smaller, so then we may need some another type of carrier. But if you can say like heterogeneous carrier technique using some other type of carrier, so then in that case, ore dilution is a problem, because then obviously at the end you have to improve the grade as well. So for in that case you need post flotation separation techniques as well. But as far as your question is concerned, no, specifically this technique has not been used in Pakistan. It's just like if you see the Sandak project, this is just they're using rougher to cleaner stage their scheme. But this technique can be integrated. Like you can just redirect the fine stream to a suitable coarse stream and make this carrier flotation happen to improve the fines recovery.
Thank you, Dr. Bilal. Any other questions? You said that these legs have effect on the mediums, the protection cells, and the pH of the protection cells.
Can you please repeat the question, because I'm online? I cannot. You are not audible to me.
Someone said that the nanobubbles that you prepare are affecting the mediums of the protection cell that is produced or creating bubbles, and the pH, just like the parametric values.
Sorry, I cannot hear you properly.
He is asking about the, I think, parameter of the flotation. Yes.
Are you asking about the components of flotation cell?
Parameters.
Parameters of what?
Parameter of flotation, like bubbles and other parameters.
So in flotation, as I mentioned, like we use the slurry, like, and then we have the bubbles. We also use some reagents which are called collectors and frothers. So collectors are used for selectivity or in increasing the hydrophobicity of the minerals, and on the other hand, we use frothers, which reduces the surface tension to make the froth stable. And then obviously different cells, there are mechanical cells, there are Concord cells, Jensen cells, every kind of cell, they have their own components. But mostly, if you see just the fundamentals, that has an agitator and the air bubbles are introduced. So then the copper mineral particles are attached to them and collected as a froth product.
Great. Thank you. Thank you, Dr. Bilal. Just before you go, what's the weather like in Balochistan?
It's too hot at site. I'm currently on site. It's around 40 degrees in here at Rekodik. So, but we are used to of it now.
Fantastic. Just before you go, just one more question.
I have a quick question. Bilal, Zishan speaking from PMDC. I'm an exploration lead in Balochistan. My question is, what is the cut-off grade of tailing? Did you work on any tailing project? What is the average cut-off grade of any tailing deposits?
Well, as I mentioned, the cutoff grade it's not like simple as like we used to do before. Like the cutoff grade at a time was 1%, then it's now came down around to 0.2% because of the innovations in the processing side. Also, that depends on the copper price by that time. So when we will be doing the processing or reprocessing the tailings, it depends not only like the techniques we are using, obviously, but the capex and the opex, and as well as by that time, what is the copper price. So that can determine the cutoff grade by that time. So it's not like I just say a number and that is 0.1. Yeah.
There are a number of parameters involved in cut-off grade. Sorry. What's the recovery percentage of this tailing process? What do you think? What is the recovery percentage? It's also
It's
very.
Yeah, it will vary because there are many factors associated with the final recovery. It's the particle size, it's the mineralogy. Obviously, first is the mineralogy, and then the head grade, and then there comes some sulfide sulfur to copper ratio. So there are some proven, or you can say we know the basics. What are the most directly influential parameters that affect the final recovery? But one of them is the head grade, obviously.
Thank you. Dr. Bilal, thank you so much.
Thank you.
The hand over to my co-chair here, Professor Shukru Talas. Very much. Our next speaker is Dr. Momentous Kemal. He is from KFUPA from Saudi Arabia, and he will be talking on global trends and potential of critical minerals for a sustainable future. So these are our best issues to other science and PPPHD. He's also became saving the vessel. The floor is yours.
Okay, can you allow me to share the screen? Can you see the screen? Yes, I'm trying to share. Hold on. Yeah, okay. Yes, can you share the screen? Can you see the screen now? Is the screen visible?
Yeah, no, it's okay.
Okay. Okay, so I'm gonna talk about the global trends and untapped potential for critical minerals for a sustainable future. I am Dr. Zakai Imad, and I am serving as Associate Professor at the King Fahd University of Petroleum Engineering and Minerals. Okay, I'm going to start with the outline of what I'm going to present. So if you see, I'm going to talk about what are critical minerals for those who don't have the background. I will talk about the global context and supply chain risks. Then I'll talk about some of the geological potential in Pakistan. Then some of the regional case studies and sustainable practices for future prospects. In the end, I would like to recommend some policy guidelines and other like kind of a summary of the presentation. So let me just begin with the minerals. So what are the critical minerals? So there are so many minerals that exist in nature. So how do we know which ones are critical? And by this question, what I mean is critical minerals are defined by every country. So each country will have its own geopolitics, which have its own needs and future needs based on the strategy they devise, and they have their own list of critical minerals. So this name critical minerals is always like sometimes it's confused with the rare earth sometimes. So these are two different things. So we need to define our own list of critical minerals. Okay. So generally, in general, many countries have these minerals as a list in their list of critical minerals like lithium, cobalt, nickel. So if we look at this list, this is generally derived by the energy transition. The electronic vehicles, energy storage, battery cathodes, all these applications are driving these lists. So basically, we can define that raw materials essential for modern technologies with supply chain risk. Now, when I say supply chain risk, there has to be some concentration of deposits. When we say about the geology, we cannot predict the geology, and the geology can be anywhere. It can be in South America, it can be in China, it can be in Russia, so anywhere. So we have to get these minerals out from these particular regions. Also, the processing is also concentrated. I'm going to talk about this in upcoming slides. So why everyone is talking about critical minerals now? It's because the demand has been raised, and according to International Energy Agency, it's going to be six-folds by 2040. So this is due to, of course, energy transition, and also the move towards the cleaner technologies. We see power generation by coal is not supported by many agencies. By many countries have already banned this coal mining and energy production from coal. So the energy transition is the key driver here. Now the challenge is extreme geographic concentration, which is creating a supply chain vulnerability. Again, if you look at the critical mineral production, we have the cobalt is being produced by Congo mostly, about 70%. Rare earth elements are generally produced by China mainly, which is about 35 to 40%. Australia is producing lithium, and also Chile in the form of a brine. It's most of the, like more than 50%, 55% is produced by these two countries. Graphite again by China. And if you look at the processing, dominance, China is the main driver for the processing. It's dominating the processing industry for all these minerals. So this is this is good for us. For Pakistan, it's really good. China is a friendly country, it's a brotherly country. The problem is for the rest of the world, they need to have a diversified chain, because this domain is being controlled by China. If they don't export anything, we rely on China to do this. So this also creates a good opportunity. We can also look into combining the mining and processing at one place, because in Pakistan we have good prospects for rare earth and all these critical minerals for different countries. So we can combine the mining and processing together, or at least establish good processing hubs to diversify the processing industry at least. So if you look at the geological treasure in Pakistan, we see around $6 to $8 trillion of minerals are distributed across 600,000 square kilometer. which is the area of France. And we see there are 92 mineral commodities, and out of 92, we can only extract half of them, around half of them, which is 52. So still long way to go. I think we need to boost our explorations and boost our mining and mineral processing industry. So if you look at the strategic resources, we do have some indications of lithium, rare earth elements, cobalt, copper. We do have good resources, gold as well. Some chromite is also present in Pakistan, antimony, manganese, all these elements. We have the mineral map on the right side, we can see. Chaghi Belt specifically in Balochistan is a prime example of this resource diversity. We do have good quality and good quantity of minerals we have. Now, what are the strengths if we go for this industry? We have a vast and diverse geology, and we have world-class deposits as in Chaghi, in Rekodek, there are lots of mineral deposits that still needs to be worked on. We have a good location. We are at the crossroads of South Asia, Central Asia, Middle East. We have a good opportunity here to lead the industry. Strategic policy, we have already identified these things, and SIFC has been created to provide a fast track investment for the investor, a one window operation. Global supply chain diversification is another thing, which is you see there is an intense geopolitical interest from the US. The US wants to go away from China, and it will be a great interest for the US if we come into this business. Again, there is a good potential for extended and advanced exploration, sustainable mining. We also have a good manpower and good prospects for establishing the downstream industrialization, which is minerals to material value chain. Now, weakness and threats. Of course, we are not contributing too much in the GDP. Many countries they rely on their mining industry, but of course we have good mineral potential. Still, we cannot do it. So there is a regulatory fragmentation, which is again there are 36 set of rules. Of course, the government of Pakistan is working on it, easing out things, establishing the mineral policies and stuff. But again, there is a lot need to be done on this aspect. We don't have the technology, of course. We don't have good technology. We have low efficient process generating lots of waste. Sometimes about 75% of waste is generated, where global it is less than 45%. We also don't have we have good infrastructure, but we don't have enough for supporting the mining industry or mineral rich areas, for example, Chaghi and Balochistan and far flung areas. So we need to do that as well. We do have a security situation. We do have a geopolitical risk in Balochistan and KPK, which are the mineral rich areas. We need to figure out this. There is a price volatility risk as well. And there are some of the stringent requirements for the ESG compliance and other stuff as well. Okay, so what we can learn now, what we can learn from international case studies such as the mines in Australia, Canada, and Chile. All these mines have shared their experience, and there are success stories. For example, in Australia, they are mining lithium, and they have a good infrastructure investment, and they have investment in the R&D collaboration. They have very stable policy regulations. Canada, they are mining cobalt. They have the good ESG compliance. They have a good stakeholder engagement, and they have the recycling strategies. Chile, they do have a water salination plant, water desalination. They do have renewable energy integration. They have public-private partnerships. So all these things, they tell us that we need to work on devising clear regulatory frameworks. We need to have investment in technology and innovation. We do need some community engagements as well, and we need to look for our environmental management system. Okay, so we do have our success stories in Pakistan as well. We do have a Sandak copper gold project. China is operating it, MCC China, and it's generating good amount of revenue. It's also creating some amount of jobs. The only lesson we have to learn from this project is we need to export the goods, not the raw concentrate. So that is the main, I think, lesson that we can learn from this project. This is one of the uh, major lessons. There are other things as well, but I think we must not export the raw concentrate. We need to process it. We need to refine it. We need to produce goods out of it. We also have to look for the sustainable mining practices, such as the water scarcity, arid ecosystem disturbance, land degradation, energy consumption, waste management. All these needs to be incorporated because the mining is a dirty process. You need to make it sustainable, to make it acceptable for the people, for the local people, for the country. We don't want to pollute the environment. So in Chile, they have been using the desalinated water and solar power plants to use for the processing and mining. In Sindengro coal mining project, third, they have earned the Alliance for Water Stewardship Gold certification, which is for treating and reusing saline water from the mine. So we do have a success story in Sindengro as well. In terms of technology and innovation, we need to look into modern technologies like the AI, machine learning. Everyone has been talking about this, remote sensing and geophysics. We need to have some of the modern methods like hyperspectral imaging, drone-based electromagnetics, and geophysics. Automation is one of the things because we need to have some of the good methods for ore sorting, haulage, driverless trucks and stuff. We need to have advanced processing techniques such as the hydrometallurgy, like the bioleaching, electrochemical extraction, and these things like the digital twins. So we need to optimize the processes as well to make it more feasible. So far, the contributions we have from is less than 3%. It has a potential to go beyond 10%. Employment right now in the mining industry is 300,000. It has a potential to go double or triple. The export revenues right now is around 4.8 billion, which can significantly improve to 108 billion US dollars. There is local value addition, which is very limited, in mostly in salt or like other things, not in copper. So we need to ensure that we need to have a good downstream processing. We need to create materials out of it, not just raw concentrate we are shipping. Okay, so here we have some examples from Australia. Australia is contributing 7.5% to the GDP. Of course, it's a big industry, and it's a big country, of course. So both ways. Chile is contributing about 10% to its GDP. Okay, so I have some policy recommendations as well, which is regulatory framework. So policy, of course, if you are going to improve in policy, it will attract good investment. Okay, uh, and these recommendations are actionable. Some are, of course, already underway. The mining investment law of 2021 is a good start. And again, there are some mineral policies of 2025. I think there was a policy which was put forward. Uh, but we need to regionalize, regional, we need to regional harmonization, infrastructure, skill development, and we need to have our give a message clear to the international partners that we are open for business and we can meet the global standards as well. So, in terms of capacity building, we need to train good people. Our own our own people must be trained in the mining, geoscience and geology. I think they're really good, doing a good job. But in terms of mining, I think they need to step up. and teach some of the good mining practices, which is being practiced around the globe. There is also compliance for the ESG and sustainability. We need to look for this. We need to enforce ISO 14001 standards in the mining industry as well. We need to adopt the OECD due diligence guidelines and develop circular economy initiatives. So in terms of circular economy, Dr. Bilal gave a very good presentation. You recycle the tailings. Also, you can have recycling of the electronic waste, the battery technology, and there are other things. You can also look into the value additions, like create the goods out of it.
To conclude. Okay.
Yes, yes. So we need to look for the ESG as well, like the environmental and social governance. We cannot neglect it. We need to figure out some ways to do it. And in conclusion, I would say the window of opportunity is open. Critical minerals are essential and supply chains are vulnerable, and Pakistan has a good potential. They have a good untapped potential that needs to be converted into something really big. So we have the global demand for critical minerals, and it will increase in near future. So we have everything. We have the geology, we have the location, we have the manpower, and vision to do things. The only thing we are lacking is some of the environmental aspects, some of the geopolitics, and some of the coordination. I think that needs to be fixed. And the opportunity is now. You see, this demand is now. Maybe in future, it will not no longer be relevant. So we need to think about all these aspects. All right, so that's it from my side. I'm leading a critical minerals research group here at KFUPM, and I would be happy to discuss any other questions from you. I would also like to thank Comstech for giving me this opportunity. Thank you.
Very clearly, in my perspective. Floor is open for questions. We have one, two. Thank you, sir. To get good knowledge about minerals. I ask you one question. Which was deposit falls within minerals?
It was not clear. Can you repeat the question, please?
Which was deposit falls critical minerals?
I think you are asking about the critical mineral deposits in Pakistan. Okay, so critical minerals basically we don't have much data for that, exact data for really concentrated deposits we have, but generally it comes with the metal deposits and igneous rocks and sedimentary rocks. Like sometimes it comes in the brine, the formation brine. So if I chalk down, you need to look into zones like the salt range, because when we talk about the brine contains the lithium. Okay, and we have a salt range with tons of salt. So salt is made up of brine, of course. So there are good prospects, I think, if you look for the brine in the salt range. Yeah.
I mean, in that sense, you give me one example about last round. In that sense, you are nickel to what?
It's very difficult to understand. I don't know what is the question.
So this question, I mean, the image halls or minerals occur intimately in tungsten. Can you give me
Yes.
what?
No.
He's asking about the host class in which anti-money detection are common.
It's not clear. I don't know. There is a problem with the internet or something. Okay, thank you.
Unmute. Okay, this is Engineer Asad Mahmood, a very good presentation giving an international context. Since I worked on the Balochistan climate change policy, some certain section of that, and also leading one of the enterprise ESG Nexus. So you also touched upon that specific topic. So in all these countries which you have referred in your presentation, have you came across like sort of having a national secondary minerals policy, just like the previous speaker was giving the example of tailings? So using the same minerals which are not in the mines but lying above and reusing those. So is there any like case study which Pakistan can follow or could be embedded into the climate change policy of specific provinces? Any inputs or insights would be appreciated. Thank you. Thank you. Thank you. Let's thank Dr. Mark for his talk. There is a change in the scheme of next presentation. The last presentation will be the second last Mr. Tom Ekem Arai, and the CEO of Pakistan Gym and Jewelry Company. And he's going to talk about the potential and opportunities of the gym and jewelry sector in Pakistan. And I'm sure there'll be a lot of aesthetic interest in that also. So over to you, Mr. Tawfiq. And let's welcome Mr. Tawfiq for his talk.
Bismillahirrahmanirrahim. Assalamu alaikum, ladies and gentlemen. Very pleasure to be here and the August forum. I would say none of the mineral experts talked about the gems presence in Pakistan. So I would share some thoughts on this. Go ahead. Pictures you will be seeing are the rare actual gems of Pakistan. These are not aesthetic or nor from any other part of the world. I will show you my presentation would be more based on the pictures rather than on words. So I believe that pictures speak louder than words. So I would like to brief you on the potential, what potential we have in the gem sector and what we can. Next, please. So this is just a snapshot of our potential. We have a heritage of 5,000 years. We have an Indus Valley civilization where we are living in this area. We have a natural endowment of minerals, which includes many minerals, including gems and critical minerals and non-metallic minerals. Regarding the gems, we have, according to the studies, more than 70 million carats of emeralds are present in Pakistan. Peridots are about 10 million carats of peridot. Ruby is about 200 million carats. Topaz is also about 9 million carats. And aquamarine is about 0.2 million carats. So what's about the industry potential? Overall, our reserves is about 300 million carats of gemstone reserves we have in Pakistan, but still are unexplored. we have just done about 5 to 10% of our potential. And we have more than 9,000 gemstone mines in Pakistan. These are small holes, actually not big mines, but these are just small holes or small tunnels that we call mines. But actual mines, we need to develop mega mines, big mines that we can actually achieve the potential. And right now, more than 5,500 businesses are engaged in this, in the trade, processing, and value addition of gems in Pakistan. Roughly, if we talk about the current statistics, we can add about 50 to 100% value addition immediately we can add in our gemstone sector. What are the major clusters in Pakistan? We have a Namak Mandi, everybody must have heard about it. It's in Peshawar. It's a processing, it's a trade hub of Pakistan and in the gem sector. Then in Karachi, then Rawalpindi, Lahore, and the mining areas are based in AJK, KP, and Balochistan. This is just a mineral map of Pakistan. You can see the mapping. We have a lot of minerals, everybody talks about it, but real problem is we haven't gone for a detailed exploration of every mineral. We have just highlighted that the potential, that here potential exists, but detailed exploration is lacking in all the minerals. Likely in the gem sector, we need to have a detailed exploration of gems as well. These are the top 10 gemstones of Pakistan, which are the brands of Pakistan or can be the brands of Pakistan. Aquamarine, these are available in Skardu, Nagar Valley, Shumabaka, best in the world. It is graded by GIA as the best in the world aquamarine. Then emerald, we have emerald reserves in Shangla, Shamozai and Mangora area of Sawat. Then we have a, sorry, it's duplicate here, Sawat emerald. It's not actually Sawat emerald, it is, the picture is about Chitral emerald. We have a Chitral emerald, that is very good emerald, exists in the Chitral. Right now, the mining has been started in that area. Then we have a tourmaline. We have a 25 colors of tourmaline in Pakistan. And then the topaz. We have pink topaz, orange topaz, and the most important and most important name is Scotland topaz. Everybody knows internationally and locally. That is best known for in the world. Then exenite is one of our best stone that is known in the world. It's from Balochistan. And then the garnets. Garnets are available in every color in Pakistan. The hosting districts are Skardu and Gilgit. Then we have a ruby. We have two districts of host districts of ruby. One is Hunza and other is Kashmir. Third is diamond quartz. These are abundantly available in Pakistan, which are used in the jewelry making and as cut. And this gives a diamond look if we process properly and cut it in a professional manner. These are found in Balochistan, Skardu, and in some areas of Gilgit as well. Then we have a wonderful stone that is peridot. Rich green color, very, very attractive color, and these are found available in Kohistan Valley and it's a Tan Valley of Pakistan. These are just real gems. I hope these pictures would fascinate ladies. I think they like more. I would like that nowadays the trend has been started that people don't like gold jewelry. They are moving towards gems jewelry. So we have the potential. But you can see that person and with the aquamarine, what is happening in Pakistan. Unfortunately, we are selling this in raw form. That needs to be catered. We are focusing that these should be processed and exported accordingly. I would share, this is one of the biggest potential of Pakistan, that is nephrite. This is also a precious, semi-precious stone available in Pakistan in large quantities in our FATA region, Mohammed Agency and Bajor. Highly recognized, highly in demand in China and UK and US. So this is one of the biggest potential that many people don't know in Pakistan, that this potential is available in Pakistan. These are the few pictures of tourmaline, colors of tourmaline. You can see everything is from Pakistan. This is just mapping of all these gemstones are in the northern parts of Pakistan, in KP or in GB. And a few are in the Balochistan region, but 99% are in KP and GB. So we saw the potential, but what are the challenges? Challenges that more than 50% of the gems extracted are wasted due to primitive mining methods. Only 30 to 40% gemstones are exported raw. 99% traditional mining is being done. What is our export value? Currently, we are exporting just $5 to $7 million of gemstones. Why this is happening? But I'm not disappointed on these figures. And any businessman should not be disappointed on these figures, because where there's a gap, there is an opportunity for the businessman. So there is a big opportunity in these numbers. The investors could come in, they can invest in mining, they can invest in processing, they can come and invest in value addition, and every part of the value chain. So on average, if you see the graph here, where's the leader? This you can see. This is if 100 carats of gemstone is extracted, 48% is wasted. Only 40 is exported or processed, and out of that, 10 is exported. And this is the story of our value chain of gemstones. So there's a big opportunity here, that it's a $1 billion industry, more than $30 billion worth of trade being happening in the world in the gemstone sector. So there is a big opportunity for the investors, for the consultancy companies. They should come in and work on this area for detailed exploration and processing and all that. So we saw the potential and challenges of our industry. Then I would like to share the what our peers are doing in this sector. What is Pakistan is doing and what our peers are doing. India is exporting $16 billion of India is exporting worth $16 billion of gemstones, and India has no reserves of gemstones. Thailand is exporting $3.6 billion of gems annually, and Thailand has even not a single gemstone reserve. India, although have a small mines, but Thailand have none of these. Then Sri Lanka is exporting $312 million of exports, and what Pakistan is doing 5.7. So there is a big opportunity. There is a big opportunity for us. These are figures are not to demotivate all of us. These figures are to motivate all of you that this is the area that we can focus on to develop our country. So what are the future plans? What government and what are the future plans, what we are planning? Recently, government of Pakistan has launched National Gemstone Policy, wherein we are going to establish a gemstone authority and to extensively focus on this sector. What we have planned to establish international gemstone centers for processing, value addition, and testing and certification of all these gems in Pakistan. Establish jewelry cities, as gems and jewelry are actually combined, because most of the gems are used in the jewelry, as studded jewelry is exported everywhere. And then we are establishing gemstone center of excellence in AJK and GB. And then one of the major initiative that we have planned in the authority, that is establishment of National Warranty Office in Pakistan, that was lacking. Our exporters were facing problem in valuation of gems. So it is being established all over Pakistan at the 5 airports of Pakistan. Then standardized labs and all these. Further, what fiscal incentives government is proposing is the tax incentives for the investors, zero rated import duties on taxes on the gemstone machinery and equipment, and tax-free imports of raw gems. Likely the India is doing, likely the Thailand is doing. They used to import raw gems and process it and then re-export. So after all these details, what opportunities are available? I discussed during my presentation that our investors can come in. They can come in to establish gemstone processing units, value addition. Nephrite and jade carving is one of the areas that we have. Most of the nephrite is being exported to China in the raw shape at a cost of $1 per kg, or maximum to $2 or $3 per kg. However, its value after processing is of one article is more than $100 or $200. It's the minimum cost. And if it's done at a good level, it goes around $10,000 to $20,000. I just show you some pictures. You can see these are all the nephrite carving that is being done in China and being exported from Pakistan in the raw shape. This industry is still, nobody knows about this industry. Very few people know about this industry. That's a big industry. Only China is processing annually about $30 billion of jade in China. And as China, I'm seeing here some Chinese people are sitting here. They can elaborate more on this. And what mining projects? Potential investors can come in the mining, gemstone mining. We have a huge potential, huge reserves here, and nephrite mining. Mechanized mining actually required here in Pakistan. Most of the mining is being done by primitive methods. So the investment is required in this sector. That scientific methods are used for mining. And what support on government part we can provide to our investors? We can provide all sort of government support because we are an entity backed by government, focusing on the development of gems and jewelry sector of Pakistan. We can provide joint venture options. We can collaborate in project implementation in every part of Pakistan. What we are looking for from the investors and technical people who have the experience in this sector, they can come in for exploration of gemstone reserves in Pakistan, and they can come and transfer the technology. If any industry, if any business is doing in this sector, they can come up with their technology for upgradation of mines, processing, establishment of laboratories, labs, and all that, and skills. Last is the skill development. We have acute shortage of skilled labor in this sector. We are trying to fill the gap in last 10 to 15 years, but still there is a huge demand, because until unless we have a skilled and professional manpower, we would not be able to achieve the international benchmarks, international standards of quality exports. So we welcome all those people who are in these trades. They should come in Pakistan, contact with us. We would be facilitating in the businesses establishment in the gems and jewelry sector of Pakistan. Thank you very much. If you have any
questions, please. Yes.
Dr. Kotik, you have mentioned about the Center of Excellence, establishment of center. Actually, I was asked by somebody to prepare a concept of establishment of this center in Gateway.
Yes.
I am from mining engineering. I prepared that, and on fine morning, I was informed that someone in the ministry is interested to establish this in Skardu. So my concern is, what is the background work on the basis of which we decide as a policy matter where to establish something and what sort of thing should be established. So this is one of the concerns. I am sitting among the miners, which nobody else yet discussed. They are highly informal. Few people, they just get together. I invest some money, I have 3 labor, and I start one. The basic hurdle is your legislation and easy process, monitoring, and all. Other thing will come after that. First, you have no control over the field. आप for example हैं, आप क्या invest करना चाह रहे हैं, ऐसे gems and jewelry वाले, क्योंकि जब mining ही नहीं होगी तो आगे value addition क्या होगी? Value addition is after mining. The first question is mining is not there. So people are coming to us because they have driven 200, 300 meter down tunnels. Now they are facing ventilation problems. So no one is there to invest in their ventilation because they are laborers, they cannot invest. They are coming to us that please help us. So as a university, we are not funding to go and help people in the field. We just have some research work. So where the funding will come, how the mining would be as you desire that it should be technical mining and it should be on large scale, proper mining. Let
me. Thank you very much. It is a wonderful question. I think your question would force me to elaborate the whole policy of gemstone that we have developed. I just named here that what's the national gemstone policy focusing on. So the current gemstone policy is focusing all these aspects that you are talking about. First of all, you talked about the Center of Excellence. Center of Excellence was jointly planned with the GB government and the stakeholders of the GB, and they agreed mutually that it should be established at Skardu. it's not limited that we will stay only in Skardu. We know the potential is in GB as well, and Gilgit as well. And the next plan is in Gilgit. The next project would be in Gilgit. We have the plan. Regarding your question of mechanized mining and waste of material and value addition, currently huge quantity of raw material is being exported in the raw shape. You know very well. If I quote some figures, our formal export is just $5 to $7 million, and our informal export is about $2 billion. So how this export is being done, you people know very well. So there is a raw material available currently. What we are focusing? We are focusing in two steps. First step is to provide sufficient processing facilities for the existing raw material that is being extracted and being exported in the raw shape. That is first target. Then the second target is that we process, we establish mechanized mines, we facilitate miners, we are establishing two machinery pools there. Three machinery pools, one for GB, one for AJK, and one for KP, where we will be providing all such machines that are required to the miners for upgradation of their mines on the standard lines. So we are catering all the parts of the value chain. Likely, these center of excellence would work on skill development, value addition, standardization, whatever the needs of the sector are, we will be trying to fulfill that. The whole gemstone policy covers the whole value chain, including one important aspect. We are trying to protect our IP rights for our stones. One of our best stones, that is one of the aquamarine from GB, Hunza Ruby. We have emerald, world-class emeralds that are being sold with the Indian brand names or Panksher. So we have extensive plan in the National Gemstone Policy, and we are working on this. I hope with the collaboration of the stakeholders, we will be able to achieve these tasks. We would love to receive your comments and your feedback and your guidance in this implementation process.
Please go ahead, sir. Okay, when you were talking about the gemstone and the export of the gemstone, I think we have to increase the value addition. That will increase that. We have to improve their quality, and by improving the quality, we can improve our export. And I will suggest one of the methods, if you have used it or not, but I have experience on that. That is radiation technology. It's very simple, and you can improve the gemstone like that. So the value addition is very essential. By that, we can increase the resources. Export will improve. So our gemstone will be complete with the gemstone from the other.
Rightly said, sir. You are very right. We are lacking in gemstone value addition. I saw the statistics, what we are doing and where we are losing. We need to focus on value addition on the currently that I already told that whatever we are producing right now, that should be value added. That should be exported after value addition, not rough. Currently, we are exporting almost 60 to 70% in the shape of raw. So our first focus is to add value here in Pakistan. So we are investing on all these technologies that are required for value addition. This is the first step.
We talked about very simple things.
Yes. So you can share with us all these details. We would like to adopt all your suggestions. These are workable. We would like to adopt all these. I would request here, if someone has any good suggestion regarding the value addition, they can share with us. We are right now in the process of procuring such machines and equipments which would be used in facilitation of the industry. So we would include, if these are feasible, we will include in our.
Let me give you an example. It is a very cobalt 60 radiation machine. When you put the gemstones there, the radiation increase the values of the product. So
We have all these machines.
Okay.
We have all these machines. We are importing these machines, and we will adopt your technology.
you have to invest for the first one.
Yes. Yes.
Very good. I know it's fantastic. Okay.
And it's good.
It wraps up the session. We're very close to lunch, and last talk we shifted to the next technical session. So you will be the first keynote speaker in the next session, and about to done opening. And let me thank my two chairs and of course thank you very much. It's such business.
Assalamu alaikum, and we are again back to first section, technical session 2. And I will be requesting Dr. Sarfraz Ali, if you can chair the session, along with where is Mrs. Zabidi? Dr. Zabidi, please join M as a co-chair for this session. And the participants available online with us. We are just going to start with the first speaker, who was the second last speaker in the first session. He will be the first speaker now. So, Dr. Sufrasa, so there was change. You might be knowing the last speaker who skipped here, Dr. So, yeah, Dr. Shukru Darash will be the first speaker of this session, and then we will continue with the same sequence of this session. The floor is with you, and please always give a timeline each of the speaker before going to speak. But that is maximum 20 minutes, and maybe Q&A we can have at the end of the session. Because sometimes Q&A is taking much longer time. If you can discuss or you continue. Thank you very much. Hello. Well, ladies and gentlemen, thank you very much for getting back after the lunch. Please, the first speaker for this technical session is Professor Dr. Taras. And the question to kindly enlighten the audience. Okay. We have 15 minutes. 20 minutes. 20 minutes. Maybe less. Okay. So I will give a typical 2 articles.
Okay. So, my name is Şükrü Talaş. I'm from Afyonkarahisar University, Faculty of Technology, and I'm really happy to be here. I was co-chairing in previous session, and I took some notes. I just want to start with them. Dr. Zeka, I think Zeka, he said, some elements or some compounds may not be, or elements especially, may not be given to the countries or companies which may be critical to some countries. Fortunately and unfortunately, you can, if the technology is not given to you, you can have the technology. You can somehow develop it. But if the material is not given to you, there's nothing you can do. So you have to beg for it, kind of beg for it. So it's very unfortunate that sometimes some countries are holding back some of the resources that is needed by other countries. So for example, tungsten's price has increased almost 3 times last 2 months and used in many sectors, especially in defense. So in defense, such as armor penetration tips are made from tungsten and tungsten carbide. Scratching tools are made from tungsten carbide. And very unfortunate that it's also used in bombs to kill people. So I understand the last one, but the other ones, or the first one maybe, but the other ones are sometimes very critical for your technology. So it's very critical to have usable amount of mining in your country or mines in your country. So I appreciate the struggle that Pakistan is holding up and really grateful. So the reliability of your partners are also important. So when you want an equipment, they don't give you, but you make it. So this is what happened with Turkey. So this many technological things were not given. Some hawk's eye or some UAV parts, but you slowly develop in your country and you learn a lot. So my talk is about high entropy systems. It used to be high entropy alloys. It started at around 2004, and it was just about metals because just alloys. But later on, it got too many varieties. For example, it's applied to oxides. It's applied to carbides and borides, and it's got complicated. Then it became composites, high entropy composites. So once you have viable system, it's easier to apply to other parts of industry and science as well. So I had to relate it to mining. So somehow we have to mention these can be used in mining industry. So one of the problems in mining is the mining equipment, especially ground engaging machines, tips, drill bits, tips, of course, they are very important, blade edges on sides, and sometimes cutting picks. Depends on your mining, what you're mining, of course, but generally wear happens in these parts of the equipments. So how can you compensate these? So the most important thing is you have to prevent wear. You cannot prevent it, but at least you have to make sure that the wear rate is as low as possible. So one of the prevention method is to increase the hardness of the surface. But as you increase the hardness, toughness is needed to be at a certain level. So there should be a balance between material loss, failure, and hardness and toughness of your material. These preventions sometimes are very expensive. Sometimes it's very cheap. So if it is cheap, which means if you can replace it very easily, in long run, it's expensive as well. So not only you're losing too much material, you're also losing too much time. So there should be a balance between these two properties on hardness and toughness in order to prevent wear. Abrasive wear is mostly dominant mechanism in these systems or in these cases. So what do we have? There used to be Hatfield steels. They are still using it, especially in crushers. And they also have high chromium white cast irons. They have fantastic abrasion resistance, and because of their carbide volume fraction, high carbide volume fraction, but they are very brittle. So hot field steels are also very good, but with low impact, they sometimes create problems, form cracks on the surface, because with hot field steels, it forms martensite when you crush it or when you hit it. So when you hit these materials, it will be very hard, but after a while, there will be some problems, delamination, etc. So these two are, there used to be a lot of these alloys, but slowly going down. Hard-facing alloys, as Professor Taif said, that's used a lot. True, it's used a lot, but you have to have certain take into certain parameters. For example, cracking susceptibility. With these tips, they're usually high chromium, high carbon tips. In order to weld these, you have to have buttering layers between hard surfacing and the matrix. So there is a dilution effect. So still, it needs to be developed continuously. So lately, and most likely an economic candidate, is hard ox steels. These hard ox steels are used a lot. Another version is used for armor purposes, but hard ox is the quite recent steel that are used for these purposes, and easier to weld as well. Another option is cemented carbide inserts. So these are used for drilling purposes mostly, and when you're using this, again, you need tungsten carbide and cobalt, isn't it? So we need mineral scientists, mining people all the time. So we are grateful to you. Thank you. So there are also problems with these materials. If you have to braze them, so brazing quality is more important. Both surfaces must be compatible in terms of thermal mismatch and also metallurgically. So extending service life of mining machines is a good business for mining, because the longer you extend, the longer you use, and you earn more money without spending too much of your resources. So there has to be a understanding between material selection, surface engineering, and component design, but these cannot be done easily without mining engineers or practitioners. So the question is, okay, we use these alloy additions, chromium, nickel, molybdenum, vanadium, silicon, etc., etc. So especially chromium used a lot, molybdenum, cobalt, tungsten, these are used a lot. So somebody came up with the idea and said, okay, look, why are we using 5% or 1%, 2%? Why don't we use them in high amounts? So let's see what happens. And that's one question. But could these high entropy alloys be used for or in mining machines or in this apparatus? Could be possible, but there are, of course, they are not alloys anymore. So they have borides, carbides, oxides. But what's interesting is in mining machining, you need bulk properties more than surface properties, because of this impact. You need to have good substrate, very hot surface. So these can be done very easily with hopefully easily. With this soil brick making, we had a problem like 15 years ago. Government of Turkey banned the use of normal soil, arable soil, and they said you have to use clay as well. So when they are extracting or taking clay from the surface, there are lots of abrasions. So people were looking for problem, looking for solutions for this problem, and they came up with hard facing. But hard facing, okay, it was working at the beginning. Because of these cheap products, in order to save money, they were spending more money. So the bulk properties are more important in that sense. So these are the materials. This will tell you the number of principal elements. Okay, we possibly started with copper alloy, then we went on with iron alloys or irons. We added carbon, we added something else. 1900, maybe we added chromium to make it the stainless steel. Then later on, we got many varieties and many different properties as well. So the last one is high entropy alloy or medium entropy alloys. These are usually the additions are between 5 and 35%, and they have different properties. For example, they give different properties. For example, very good magnetic properties, very good surface hardness, especially if you are doing second phase hardening, and it gives you fantastic properties. But of course, they still have to be investigated, and somebody has to take the blame for the research. And the idea is that if you take one composition, you have to make sure that everything is studied in that composition. Well, in that case, we would say, okay, how many HEAs or how many high entropy alloys? It started in 2004. In first 4 or 5 years, there were 100 publications, 200 publications. But this, for the last year, there were almost 2,000 papers came out with these alloys and carbides and, of course, borides. So it's getting more and more popular. Thanks to mining engineers, we have more and more material boron, etc. So we can play with these materials very easily. So the idea is, I will also come to that, but the idea is mix as many atoms as possible, so it will have it will have some effect of let's say sluggish movement of atoms, slow diffusion, etc. Well, the person who, or people, two people actually, the people who invented or used these, they thought if you mix this one, maybe we can have many different phases, but they realized that there's only one phase, sometimes two phases, but those phases are usually not in alloy form. It's usually in pure form, the second phases. So they are in fact metastable. So this enthalpy changes is driving their unique properties. But name is entropic alloys. So these systems usually they are designed to be solid solution, usually single solid solution, and solid solution strengthening is also expected through Hund rotary system or Hund rotary rules. But unfortunately, and again fortunately, because of these high number of atoms, these solid solution strengthening doesn't really fit in Hund rotary rules. So Hund rotary rules fits very well with if you have a molar ratio versus activity diagram. On both sides of the activity diagrams, it's very dilute. In these regions, in these activity fraction, mole fraction diagram, in these first zones, it's very easy. They are rolled alloys, which means ideal mixtures. So ideal mixtures are very good, but when it comes to 50%, 30%, 50%, it becomes more entropic. So they become Henry alloys or Henry determined by the Henry rules. So high entropy alloys, in fact, doesn't exactly obey the rule of Hund rotary. But what we are looking for is increased hardness and toughness, and also very, very, very importantly, high temperature stability. So the idea is high mixing entropy, 5%, 30%, and we are trying to increase the entropy of mixing. The idea is very simple: add as many elements as possible, so mix them up and see what happens. The core effect is due to lattice distortion, because smaller atoms, big atoms, and sluggish diffusion. If you mix big atom, small atom, all these small pores, let's say pores, in the lattice is usually blocked or very small, so they cannot move very fast. So the cocktail effect is similar to sluggish, or can be explained by sluggish diffusion. A cocktail effect is same as big atoms, smaller atoms, or high oxygen affinity atoms, low oxygen affinity atoms, so speaking fast. So these kind of effects are taken into consideration with high entropy alloy systems. And most importantly for researchers, it's a vast, largely unexplored area. So these are, maybe you remember, maybe you don't like this one, but this entropy concept comes from Boltzmann equation. So it's a classical thermodynamics issue. So if you increase the W, you will increase the entropy. So the CI is here is very important. The number of, as you increase the number of CI, the constant before R, 161, goes up. So if you increase the number of elements more than 5, it becomes 161, 2.0, etc., etc. So here, entropy level, we are talking about seal on the left side, and we are talking about high entropy alloys on the right-hand side. So as I said, it used to be alloy, but it's not alloy anymore. As you can see, there are so many alloys, and these are just metallic ones or just alloys. But you can have all sorts of high entropy alloys. Started with transition metal, then they went on with lightweight high entropy alloys. Then they needed high temperature stability. They used refractory atoms, elements, and etc. etc. 3 minutes. Okay. So these are, as I said, it has changed. So these are the high entropy oxides, high entropy borides, high entropy carbides, and you can also find without B as well. So it's got more and more over the years. So there's approximately, the last time I read, maybe a few months ago, there were at least 10,000, more than 10,000 different alloys, just alloys, not, it doesn't include oxides and carbides. So this is Abbey's plot, and you can see yield strength and fracture toughness. So these high entropy alloys going up and up, and I believe it's filling the gap between yield strength and high strength and fracture toughness. That's why it's important for mining industry. And now the system has become composites. So all these properties can be obtained with the mixture of these oxides, ceramics, or rather ceramics, let's put it that way. Could be different ceramics as well, high technology ceramics as well, high entropy alloys. As I said, the important thing here is wear resistance and thermal stability in addition to mechanical strength. So this is how you produce them. Ideally, we use arc melting method, but there are other ways of producing. For example, mechanical alloying. It's very nice. I mean, very, very easy, not nice, very easy. And but we use mostly we use arc melting. If it is with different melting points, then you use mechanical alloying. If you have different purposes, then use one of these methods. So these are a small summary of it, and you can see some examples. and now became composites. We started from alloys, then we ended up in composites. So it's developing quite fast. Where they are used? Aerospace and defense, energy sector, especially hydrogen storage as well. It's becoming very popular for hydrogen storage, especially batteries. And there was one application I just want to mention. This one, slurry pump impellers. There was a study on this, the tips of it with high entropy alloys. It worked very well, but needs to be tested quite long term. Pros and cons: expensive. Design limitations may be imposed, but specific altering is a plus. And coating can be very easily applied. Thank you.
Thank you.
You have any
questions? Any questions, please? Just a comment, you praised mining engineers.
Yes.
So as a favor, you got extra minutes.
Oh, thank you.
I have one question.
Sure.
Sir, I want to ask you that before starting any mining operation, underground, internal, we carry out first geotechnical investigations. I have carried out geotechnical investigation by myself abroad, but I have never seen in geotechnical investigation that they elaborate that what type of metals, they should also elaborate in the geotechnical, what type of metal like bits, like rods, like teeth, it should be used in mining operation to avoid corrosion and corrosion of the metals.
In this respect, it can be adjusted to high corrosion resistance properties. It's possible, but your main problem at the beginning is not corrosion. Your problem is wear, especially the wear is big problem in your case. The secondary is corrosion. Because you're always carrying out abrasion, two-body or three-body abrasion. So if it's two-body abrasion between two, three-body abrasion, abrasive is between two surfaces, and maybe it doesn't apply to you, but abrasion, two-body abrasion is mostly your concern. And also impact. Maybe it's good for those, what do you call them? To make smaller, you have those machines to make smaller stones. From the big one, you crusher, okay, crusher.
Yes.
So crusher might be a good example for that, but corrosion is, of course, it can be changed. You can add chromium, or you can add some other elements. Depends what sort of corrosion you have.
Like, sir, I have seen in my old experience that we are using like from carbide bits, diamond bit, and every bit have their specific, what you can say, specific
properties.
Properties.
Because some of them are made with cobalt. So in order to not fuse actually, but alloy, through alloying, surface alloying, in order to make them bind together, tungsten carbide, you have to go up very high temperature. So I don't want to go up to 2500 degrees. So what I use, cobalt, and cobalt will bind them together. Or sometimes if they want to make it cheaper, they use iron to make it cheaper. So those two differs a lot. If you're using cobalt, it's way better. But iron, it's less better than cobalt, for example. As a
and this painting Apparently,
We discuss that in the middle. You can have you can have discussion later. Please don't forget your question. We can discuss later.
Excellent talk, sir. And you're still doing electron microscopy you used to do in
We still do. I still do. I like the
You mentioned about equiatomic complex composition.
Yes.
Can we use machine learning, large language models, AI to have simulation for the composition?
Yes, there are new models coming up with these what's that program to produce phase diagrams. And they have new editions. I couldn't remember the name. One of them was Thermocalc. And then there is another company. Thermocalc introduced this high entropy alloy systems. Possible a few years back, but it's still they still need lots of data for that.
Very much. Thank you. Next time talk. Very valid.
What the next I would like to invite Mr. Family, CEO of the Giant China, with the title of Liquid Oxygen Technologies Application in the Mining Industries. Oh. 20 minutes. So you have 20 minutes for the presentation.
先生，下午好。
Hello everyone, good afternoon.
我来自于中国。
I'm from China.
我今天带来一项新的技术。
Today I have new technology.
在汇报之前呢，我请大家先看一下。
Now I want to show something to you, okay?
大家看到这些视频了。
Just now what we saw the short video.
用传统的理念想，是不是爆破？
Maybe all of you think this is explosive, right?
但是呢，我们这项技术呢，完全不是爆破，没有任何爆炸物品。
But this is not explosives. No any chemicals and explosive, no gunpowder.
众所周知呢，几千年前中国发明了火药。
As we all know that 2,000 years ago, China invented the gunpowder.
然后呢，我们这一代中国人呢，经过50年开始，一直研究到现在，我们发明了一种完全不同于传统爆破的一种新技术。
After the years of the research and exploration, our team, okay, and developed a new technology.
我们刚刚看到的所有的视频里面，没有任何爆炸物，没有任何爆炸物品。
Without any explosives, without any chemicals, just in the shot cameras.
这项新的技术呢，完全颠覆了传统的那种爆破。
This technology completely overturned the traditional explosives.
因为英语的问题，所以我请我的助理呢，把 PPT 呢用英文全程的讲给大家听。
Because as you know, on English,
And now I want my assistant, Peter John, to, on behalf of me, to give you our English presentation. Okay. So today our topic is the liquid oxygen phase change rod breaking technology. Part one, that's the technology background and rod breaking mechanism. Okay. So now is there three section of the Okay. Sure. Yeah. Driven by industry development, in project with complex environmental conditions, the use of civil explosive materials is often prohibited. We all know this, right? The liquid oxygen phase changer gas expansion technology enables rapid rod breaking of addressing the efficiency of mechanical methods and cement expansion agents, and driven by counter-terrorism needs in regions facing severe terrorism threats. This technology significantly reduces the security risks associated with their transportation, storage, use, and potential theft of severe explosive materials. And driven by work safety requirements, unlike traditional explosive blasting, this technology does not produce harmful effects, such as blast, shock waves, ground vibration, or toxic gases. It substantially enhances their intrinsic safety level of mining operation. Why we innovate the liquid oxygen phase changer gas expansion technology? One is to overcome the difficulty of legally obtaining explosives and other blasting materials. It actually is very hard to gather explosives. And two is eliminate the need for strict and complex approval procedures required for using explosive blasting, especially in Pakistan. And three, to ensure high on-site operational safety and manageable risk. The equipment and material involved are not classified as dangerous explosive items. Four, significantly reduce the fire's emission compared to explosive blasting, thereby increasing the yield of usable ore to eliminate the harmful effects inherent to explosive blasting, such as shock waves, toxic fumes, and excessive noise and vibration. So this is a state diagram of explosive detonation in rock. You see this picture, and after detonation, the pressure reaches tens of thousands of megaparts and temperature exceed 3,000 centigrade. This high temperature and pressure cause the rock around the borehole to melt and pulverize into fine particles, creating a caustic zone and causing resource waste. The combustion phase changer coupled model. Our theoretical model showed that liquid oxygen phase changer has gas expansion, almost the combustion phase changer coupling model. The solvent is ignited, burning rapidly with the help of liquid oxygen, releasing heat and carbon. Simultaneously, the liquid oxygen absorbs heat and vaporizing violently. These two processes are tightly coupled, generating a large volume of high-pressure gas. This is a controlled energy conversion process, resulting in a relatively mild and sustained gas expansion.
就刚刚说的，全世界的爆炸呢是具有爆炸波、冲击波、振动波及热能，而我们的这种气体相变的过程呢，这四个要素一个要素都没有。
As in the world, explosives will produce their blood, shock waves, vibration waves, and oxidate gas. But our technology knows this influence. So the main equipment for gas expansion rock breaking. Okay. This section is special introduction to our equipment. The core system consists of three key components: intelligent filling machine and dual vessel, and flexible energy storage tube. You see the blue, white, and red. The evaporator plays a critical role in vaporizing liquid oxygen to build pressure within the system, ensuring a consistent and stable filling process. Flexible energy storage tube composition is a plastic casting, combustion supporting medium, and filling exhaust tubes and ignition elements. The filling tube is insulated to maintain a liquid state of oxygen, preventing premature vaporization before it reaches the tube. Rock breaking mechanism. Step 1, or energy generation expansion. The energy storage tube is inserted into the borehole and filled with liquid oxygen. An electric igniter heats the absorbent to 600 centigrade, causing rapid combustion. This intense heat instantly vaporizing the liquid oxygen, leading to a volume expansion of over 800 times, and generating an internal pressure of up to 250 megabars. Step 2, rock fracturing and ejection. The generated high-pressure gas acts on the borehole wall to ignite cracks. The pressed gas then penetrates these fissures, functioning as a gas wedge. This wedge effect propagates the fractures until the rock breaks off and is safely ejected. And our safety research. So safety features: no severe corrosive or explosive pressure, and items involve no large shock waves. Just now we talked about low peak vibration during rock breaking, no gas-based chamber if ignite outside the borehole. Just now, as the fund said, no these negative effects. Okay, pressure test started inside the borehole. Okay, it's a lab run with very professional analysis data. Okay. Rock breaking vibration test started used in the mountain on-site vibration measurement data analysis. Vibration velocity attunes rapidly with the distance in one test using 215 L of liquid oxygen. The maximum vibration velocity measured at 20 meters. 20 meters are only 0.26 CFS. Compared to an equivalent wheeler explosive, the vibration from gas expansion is 10 to 20 times lower compared between gas expansion and explosive blasting. Very clear difference from energy release, pressure, and the fast rate and safety have their effects. So connection of charging pipes in couples bamboo parachute cut depths. In the tunnel, we founded our experiments. Excellent protection of surrounding rock, high up over it. We did our findings, excavation area, and drilling marked down circle time, rock time. Inside the liquid oxygen phase chamber expansion rock breaking method is a gas-based rock breaking technique that is safe, efficient, and environmentally friendly. It improves operational safety and significantly reduces the regulatory burdens on management departments, safety, efficiency, and environmental friendliness. All these aspects we're worried about, especially the miners worry about it. Recent research achievements. recent publications. As you know, Mr. Van Eng is also a senior engineer. He recently published a lot of the very perfect articles internationally. And currently, Ms. Van Eng already registered an external local company, and with their management team. The company name is Engineering Private Company.
就是这项技术呢，我们已经在巴基斯坦成立公司，与奥地利大学已经进行联合，把这项新的技术、新的产品已经在巴基斯坦生根发芽了。
And up to now, my new technology already cooperated in the KPT university and already applied in some in practical.
所以这项技术呢，完全是颠覆了和改变了传统的爆破模式。
And this technology already completely overturned the traditional explosives.
所有的物件、器材没有任何是管控物品。
All the materials and opponents does include the prohibited items.
所以巴基斯坦的矿产资源非常丰富，如何把它开采出来？
According to my experience, Pakistan has a rich resources of mining, but how to excavate it?
那不是一句口号的问题。
That is not an empty slogan.
是从根本上要解决如何开采，这是第一步。
And we should actually to improve technology and excavate.
但是当前的局势又是这么紧张。
And as you know, the current situation is severe.
如果用上这项新的技术
，If we use this technology,
所有的矿产资源都可以开发。
all the mine resources can be.
而别有用心的一些人拉到我们的产品，他最多就上，只是卫生纸。
If some companies or someone wants to do some better things, to do some trick things, use technology, but as you know, it cannot destroy the environment. You cannot do some bad things with this because we have our central materials in our hand.
在露天和常温下，它只是燃烧。
In open ground, it only burning without explosives.
但是放在我们的矿产或者岩石里面，采取一种密封，那么它就可以起到开始的视频效果，把岩石胀裂开来。
But if we use this technology in the mine, in the bone hole, it can be expansion, and without any other chemicals.
而且说的炸药的4个要素，咱们这个一个都没有。
And as you know, there are 4 elements for the explosives are here without any.
所以说，这个也是一种对传统爆破的一种颠覆性的革命。
So that's why I say this is a completely overturn for traditional explosives.
所以我的汇报到此，看看大家有什么疑问。
Thank you so much.
You're not one or two. You have any question?
If there is any economic analysis to compare with the traditional blasting, which use of explosive, 100 cubic meters of rock, if we break by explosive using and that 100 cubic meter by your technology. So which one is cheaper?
Oh, you want another cost, right?
Yeah.
大家用那个传统炸药和这个咱们新技术同时破100平方的这个方式的话，你那个成本这有没有明显的一个数据对比？
有数据对比。
Yes, we have it.
关键看巴基斯坦对炸药的价格管控的问题。
It depends on the price of explosive in Pakistan.
Yeah. This is quite expensive.
在中国对比的话，我们比炸药成本要低。
As in the China market, we do such comparison. It's very cheap compared to the explosives.
Another question?
Yes. Yes, please. Mr. Dr. Khan would ask you about the cost. The cost of explosive compared to the liquid oxygen. What about the yield? Which is one of the most important parameter after the blasting.
还有这个产量，在这个爆破之后，多少产量，哪会好一点？
这个没问题。产量呢，总体方量来说，我们进行过一次有1万多方的那个膨胀也有过。
OK， 1万多方。
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 对，一次性1万多方。对。
And as you know, we did our experiments on site with 10,000 centimeters, 10,000 centimeters experiments.
He is talking of the fragmentation.
Yield, sir. I am asking about the yield. Quantity of the oxygen, liquid oxygen used, and it is giving the tonnage. So, how it will affect the comparison between the commercial using of commercial explosives?
Symbolic of the
yes.
frozen rock.
Yes.
It's basically talking about the powder.
No, not powder.
I'm asking about yield.
OK， 您解释给他听。
Zero is output, right? Yield is output coordinate. 当时那个是
您跟他解释啊，这个气体膨胀呢，我们现在做的试验最多的一次1万方。
As I know, you want to know the yield means output. Okay, use our technology. What's the actual effect, right?
它现在主要解决的问题是安全性。
So the key point we want to
可控性
solve is safety and easy to control.
对居民的震动和扰动性。
And no any destroy to the surroundings.
所以产量肯定没有炸药那么大的威力。
So that's why it's yield and outcome sure not big than the explosives. It's a little smaller than yes. I know you want this question.
Yeah.
Thank you so much.
Okay, thank you.
Ladies and gentlemen, we now invite Mr. Hassan Mahmood Lakwi. He is General Manager Strategy and Commercial of the National Resources Limited, Noida. He will deliver a talk on unlocking the $1 trillion blueprint. Mr. Hassan Mahmood Lakwi.
Hello, assalamu alaikum. Let me just load the presentation. I'm just going to, hopefully everybody can see it. Do you have a clear view of the presentation?
Mr. Lakwi, you have 20 minutes.
Okay, thank you. I patiently waited for this presentation, obviously. Heard about everybody, especially Mr. Zabidi, Mr. Zakaima, Dr. Bilal, Dr. Suru, and Dr. Feng Yang, and they, mashallah, covered a lot of technical details. So obviously, me coming from the strategy and the commercial side of the mining arena and the business area, so I would be making this presentation more commercial instead of technical, so that we have a full picture and what exactly should be the recipe for Pakistan to succeed and how to unlock this $1 trillion worth of wealth which we forecast and publicize everywhere around Pakistan. So first of all, I would like to introduce, basically, I work for National Resource Limited, and I'm the General Manager Strategy and Commercial over there. National Resources is actually a conglomerate of 3 most popular partners, business firms, which are basically Fatma Fertilizer, Liberty, and Lucky Cement, and they are very good sponsors. We are under the leadership of our CEO, that is Mr. Shamsuddin A. Sheikh. He's a mining veteran, and his knowledge in Pakistan mineral sector value chain is among the Pakistanis which I have seen is very, very enormous, and he is a very aggressive leader, and he is leading NRL with great success. So we can proudly say in the exploration world, NRL as a local company is performing good. We have international consultants working with us. Despite all setbacks that we have come across, our attitude is basically to rise again and lead Pakistan to the future. So let's start, everybody. Thank you for your time. Let me come to my presentation. Obviously, most of the slides that I would be covering over here, that is 4 or 5 slides, have been actually covered by Dr. Zaka Imad and Dr. Bilal. I mean, their presentation was great enough. They have already covered the critical demand section. So bear with me, bear with the pain, and let's start the presentation. So let's understand in the long run, basically, we are in a phase where an energy transition is going on. The demand of all the critical minerals are exceedingly growing, obviously, and we don't have enough mines to produce them. The thing about mine is it has no terminal cost, which means it's a business that is going to finish after every year. Your resource is going to decrease. That is, your reserve is always going to keep on decreasing because you're extracting your minerals. So obviously, a lot of work, a lot of investment has to be done in those area, potential area, prospective areas where things have to be developed because our demand is growing for critical minerals, and it's just not Pakistan, it's all over the world. So the Oregon group, basically research and analysis group in mineral, basically, they estimate there's somewhere around 500 to 600 billion dollars of worth of investments have to be done in the mining sector just to bring this up to the par capacity, just to meet your supply and demand gap. Now, what are we have to do? Looking at today's scenario, Pakistan has remained actually strategically neutral hub, and we do have the prospectivity, but we don't have the capability and the capacity, the financial capacity to extract these minerals. We might say we have $1 trillion that is beneath the ground, but to make it economically viable, we need a lot of efforts and a lot of hard work. However, the Pakistan's diplomatic front and the foreign front, they have successfully marketed Pakistan as a strategically neutral hub. I mean, the recent example is the US-Iran talks recently, making Pakistan the center of attraction. And we somehow or the other, we know how to leverage our prospectivity. So we have achieved the first part of it, but the second most important part, which is the most important part, that is exploration. You might be prospective enough, but we need to make sure that we continue with the exploration, develop MREs as per international reporting standards like NI or JORC, and further on, then we can attract investments. Without that, nobody in Pakistan will invest. So seeing that we have a lot of wealth that is beneath ground in situ, in the end, we will not get anything unless until we develop international reporting standard reports with international qualified consultant. This is the only way we might attract investment. So I'm just going to give you a brief rundown. Basically, if you can see the chart, the waterfall chart, this is as per 2023 world mineral economy. The world mineral economy produced $1.3 trillion worth of minerals. Unfortunately, Pakistan made only 2 billion. They exported minerals and they produced. And out of this, that is only 0.15%. If we want to be something, if we want to be basically a mineral state and we want to be economic prosperous, and that is the only hope, we need to take our GDP to mineral, that is to ratio to 6.7%. Our mining contribution should be average touching 6.7% to our GDP. This is where we have to come in. However, experts and basically local critics in Pakistan, they say that we don't have the framework, we don't have the right equipment, we don't have the technical capacity, we don't have the financial capacity. I totally agree on this scenario. However, companies like NRL, Mari, Meadow, Karakram, I mean, they are making an effort, an all-out effort in this high tense geopolitical situation to develop these resources. So I'm going to go through step by step how we are going to do it, and from there onwards, we're going to move ahead. So everybody has seen this map. This is a geological endowment map, and this covers basically, just hold on, just hold on. This actually covers the whole region. It's the Tatian metallurgic belt. Everybody knows about this, and it's one of the most prospective belt. But how much of it is explored and how much of it has been proven? I would say only less than 4% of this is actually proven. The remaining, we are still yet to explore. We still have to gain momentum. The reason being is, why are we not gaining momentum? Because we don't have access to the right technology. We don't have the right skilled people for it. And we have to import each of these things, even the technology, the right HR skills, which are very expensive. Hence, we are facing a huge crisis in developing these resources. One thing that I would like to mention, the success of Recodic is basically very important for Pakistan. It is basically an investment enabler. If Recodic is successful, mining in Pakistan will be a great success. So, as a Pakistani, we should hope that Recodic is successful, because this will be one of its, I mean, this is one in a lifetime opportunity for Pakistan, that to showcase the world that this is the point where we are ready for mining. Totally agree. There could be a lot of problems, a lot of geopolitical issues. But when you are in the mining business, especially in the mining business, one has to understand you need to be very aggressive, you need to be resilient, and you need to have an attitude basically to get up no matter how many problems come, how many bottlenecks are there. You need to get up again and rise and keep on working till it is fruitful. So we are expecting, if Recodic, for example, rises to the equation. So there are a lot of small mines coming. Obviously, Recodic is a very big mine. When I say basically medium or small, I mean a 300 million tons to a 1 billion ton mine will be popping up in Pakistan. Obviously, a lot of exploration activities are going, and they would have access to all the funds, the World Bank funds, ADB funds, and we can develop this economy into 10 to 15 billion dollar per annum income. And this is huge. So this is why we all have to pray for the success of Recodic, and it is very important. Everybody speaks of basically we exporting our raw materials or concentrate. I mean, there are different companies which are actually doing it right now and exporting it to basically XYZ, China, to different countries. But we don't have an industry made. I mean, if you want to do smelting and refining in Pakistan, that is to develop this midstream, energy costs are very high, and no one will be able to invest. And when you install a smelter or a refiner, you need huge capacity, you need a lot of ore feed. So obviously, a lot of people have done their feasibility studies, and it is all dependent on high, huge ore feeds. So we need to develop this. I totally agree on it, but it will take time. However, we do have a downstream manufacturing industry, especially if you look at the Gujranwala sector. I mean, we have a huge mining sector. When I say urban mining means the recycling part of it. We do have that component built where we are recycling materials, we are importing scraps, and we are making into new things. So we do have that 10 to 20% of the downstream industry built. All we need is investment and impetus to build this further. Coming to the midstream part of it, we have to selectively build. We need to have a lot of mines, and this is how we are going to be successful. If somehow we build all these industries together, we can save a lot of foreign currency. We can save on the current account deficit can definitely go down. We'll be saving somewhere around $5.2 billion annually. But again, this is all subject that is we keep on continuing to work hard and achieve this mission. Now, when I say mining, so what exactly is the economic and the business model of mining? How do people see it? How do investors see you? When you develop a resource, when you explore, how are they evaluating you? What is their mindset? So what I'm showing you over here is a Lassonde curve. This Lassonde curve actually will tell you how the value is evaluated and how long it can take you. So I'm going to use a copper porphyry example, which worldwide average is 15 years from point zero, that is you're starting to exploration, all the way to develop a mine. So the industry average is 14 years. Now, looking all this scenario, so I'm going to come to this point. This is the area where you apply for an EL and you have the legacy data, maybe from GSP, from different historical data, USGS and everything, and you start exploring your mine. You do your scientific studies, you do your geophysics, and slowly, gradually start drilling. It is at this pace where you do your discovery, and that will lead to your pre-economic assessment plus MRE inferred. This is where you get the maximum value. So if we reach this value, that is P plus MRE inferred after discovery, so we can make sure that we can attract a lot of investment. All we have to do here is to reach over here, and for this we need high risk capital. Obviously, mining is not easy. So for example, if we are basically doing exploration in copper porphyry, not all copper, there could be copper beneath the ground, but it is not all viable because whatever comes out of the ground has costs associated to it. If they have costs associated to it, obviously it has to come out, it has to break even, it has to make a profit. So this is the whole battle that we are into. All we have to do is reach here, and then your investment will technically flow in. Now, coming to this point, once the investment flow in, then your development phase start. We call this the orphan period in the mining life cycle, or obviously the business life cycle of mining. Here, when a company invests over here, they know you need to apply for MLs, you need to do your water studies in depth, there are a lot of restrictions that are going to follow in. So there are a lot of gaps into it. So even after investments, there are a lot of downturns that we are going to face. But hopefully, once you overcome all these factors, this is the point where you reach that generational point. One mine that can lead up to 27 years of basically mining, and you keep on further exploring, you can increase your profits. It's generational wealth. So basically, Pakistani companies, which are the top 20 or top 42 companies of Pakistan, if they want to do this, they need to understand this is a high risk, high reward business. And it takes time to achieve success. And not every time it will be successful. For example, an average for a copper porphyry to become a mine, the probability is 1 is to 500. Some say 1 is to 1,000. So basically, you look at 1,000 area, you start working on it, only one of them becomes a successful mine. So it's huge capital, high risk, but it's high rewarding. These are all generational business. Now, coming to the main point over here, which I want to say is basically you have all that wealth beneath the ground. Now, is there a tangible solution to this? So, I will be going a little bit religious on this, obviously. So, I'm going to give you, there is a surah in the Quran, that is Surah Yusuf. It says, verse 43. It's a story basically where a king of Egypt sees a dream, and he sees basically 7 basically green ears of corn and 7 dry ones. And he asked his people to interpret this dream. So the Prophet Yusuf, he provided the recipe, discipline, planning for this dream. It was basically, Egypt was a very fertile land. But however, due to floods, due to mismanagement, due to no planning, no storage facility, it never got there. And it'll be very surprising It is the same resource management of 14 years which we have of copper porphyry. So if you eclipse this to the same wave to the mining sector, that is to make this thing into economic reality, especially for Pakistan, our $1 trillion potential from in situ, we need to plan. We need to develop all this. We need to make it economically viable. So this is the lesson we learn from the Quran. And obviously, a book 1400 years old, obviously teaching us to do it, and it's just following the same principle. This is how your MRE is made. Your reporting all your reporting codes are structured in this way. If you look at it and the lessons learned from those days, I mean, it was very simple. Those same terminologies, those same methodologies have been applied. That is social license to operate, your community well-being, everything that has come for these reporting code, actually it matches with Surah Yusuf verse 43 onwards to 48. I mean, it is literally the same thing. And we just need to eclipse it for our mining purpose and to develop Pakistan. Now, coming over here in Pakistan, we do understand there are a lot of risks. So I'll go through all the risks again. So let me discuss the strategic and geopolitical risk. We have supply chain vulnerabilities. We have geopolitical and regional instability. We do have problems. Then we need to empower our community. We need to basically have this social license to operate. We need to have community involved at all time. Then we do have security risk, operational and technical risk. Let me say this, we don't have the exact talent in Pakistan that can develop the technical capability to develop our resources. And we have to get very expensive consultants to look into our work. Then exploration in Pakistan is very expensive and very high cost. For example, in Australia, per drill meter, if you use the KPI, is $300 to $400 per meter. Here, the exploration, if you want to do it, that is a diamond bit, and I mean, obviously, you want basically to drill deep somewhere around 1,000 meters and to see whatever the minerals we have. To get those cores, it costs us somewhere around $500 per meter. It is very expensive. Now, and what we have noticed, the local companies over here, especially, they don't have the right resources. Even those people have to call down technical experts from around the world to drill. Then we need to build a technical HR capability. We need to train our people so that in the long run, they can run the show. This is very, very important. And we need to develop their skills. The fourth and the most important is we lack infrastructure. We don't have a proper planned road network, the railway network. We have huge water scarcity. Our people are neglected. So all these things, they add up to the risk factor to make a mining in Pakistan successful. However, work is being done and I really appreciate that, but a lot of work still has to be done. And this has to be a collective effort. This effort has to be done from the government, from the civilian, from the geoscientist faculty. Everybody has to come in, put their effort in, and make it successful.
We are running out of time.
Yeah, I'll just breeze through it. So obviously, in the end, I just want to say about SIFC, basically, I mean, there are a lot of things, but I need to commend efforts of SIFC. They have launched a mineralization framework. Unfortunately, people don't understand. They haven't read it in detail. It does provide stability. Obviously, I don't say, I mean, you cannot have differences with it, but it is good enough and it does meet a lot of jurisdiction that is worldwide. SIFC is also enhancing security and do understand the geopolitical instability that is there. They also do understand that Recodic is the flagship product and for economic hope. So the most important point is for a local company over here is developing a mineral zone with tax incentives. Now, for example, if something costs me $400 to $500 for a meter drill, you can imagine I have to pay almost 30% tax. That's $120 to the government. Now, if I save that $120, I can train people. I can do a lot of things. I mean, companies can they train people, they can send the people for resources. We can do a lot of things. So we need to somehow work this out as well. Again, technical capabilities have to be built. SIFC is doing a great job of it, obviously, and must be appreciated. But again, a collective effort has to be done. Thank you.
Any questions? Any question? Thank you very much. Thank you, Hassan.
Welcome.
The next presenter, next speaker, I will make the question from the Science Ministry. The title of presentations of predictions of limestone rock type, application using an online vision system.
Assalamualaikum warahmatullahi wabarakatuh, everyone. Good evening, all of you. So my name is Dr. Kuashani binti Kuisa. You can call me Ashra, but some people call me Ku Ashra. Some people call me Ash. Some people also call me Honey. So it's up to you. Okay. So I'm from the School of Materials and Mineral Resources Engineering, basically from the Mineral Resources Engineering program. Is the only one in Malaysia. Okay, so today I'm going to present to you on the topic of creation of limestone rock type classification using an online vision system. So basically, this is a collaboration project between a core industry in Malaysia, which is located in Ipoh, with USM. So before we start, so let me give a background of this project. Okay? So limestone is widely used in cement production, steel manufacturing, aggregates, and also construction industries. So different limestone grades have different industrial value and also applications. So basically, what have been doing in industry is that this grade have been determined by the chemical composition and also the physical properties. Yeah, and then consistent limestone quality is also important for efficient downstream processing. So that's why it's very important for us in order to do the quality control, to segregate and also to what we call sort the limestone properly, because it will affect the downstream process and also the operational process. Okay, and then that's why they are proposing us and together, okay, we want to develop the online vision system and also rapid quality assessment. So because the current optical sorting enables rapid limestone classification during industrial operation, and the brightness characteristics show potential correlation with limestone chemical composition. So what they have been doing is that they classify or they sort this limestone based on the brightness, which is the high brightness, regular brightness, and also the low brightness. Okay. So online vision system will support rapid and also portable preliminary limestone quality assessment. So what they have been targeting is that they don't want they want to standardize this human what we call as decision. So sometimes they said, maybe this person said, okay, this is very bright, but for some person said that, no, this is less bright. Okay, so they want to standardize that. Okay, so and then they add one more is the XRF validation is required to confirm the actual elemental composition of limestone sample. So in addition to that, they want us to do the elemental analysis in for the particular grade of the limestone. Okay, so what is an online vision system? So it's an automatic system that uses cameras and also optical sensors to identify and classify limestone material in real time during conveyor operation. I don't know why the picture is missing over there. Okay, then we have some picture. Okay, and then how we do that is that it captures limestone surface image continuously, okay, rapidly, and it detects visual features such as color, texture, and also appearance. And based on that, it sends the classification signal and to the sorting system. Okay, why is it important? Because it enables rapid and also non-destructive limestone quality assessment. Okay, secondly, supports real-time industrial material classification. and it reduced dependency on the continuous laboratory analysis. So currently what they are doing is that they took the samples every hour and then bring to the lab and do the lab analysis. And so they want to reduce that. Okay, so it is hoped that with the database that we have created, it can be reduced for the lab analysis. Okay, and then improve sorting consistency and also operational efficiency, and also show potential for portable or smart core application. So what they have been asking is also that maybe the workers have some like apps application on their phone, so that if like they put the camera on the line, so they know what is this, it is high brightness or low brightness or some sort of that. Okay, and then we will also integrate it with the vision system with the MFIS model. So basically, this MFIS model is an adaptive neural fuzzy inference system. Is the combination between the ANN, which is the artificial neural network, and also fuzzy inference system. It is hybrid system. Okay, and it is for nonlinear prediction and also classification task. So if you can see here, this is the MFIS model. So here is the input, and then we have several layers of the fuzzy inference system, and then we have the output. Okay, so why is it important? It is because it will predict element composition based on the optical image characteristic. Okay, and then integrate visual features with SRI validation and improve intelligent limestone classification capability, which is the target is not only on the brightness itself, but also on the elemental compositions. Okay, and then it shows potential for real-time industry conveyor belt application. Okay, but there's some problems that the existing optical sorting system are highly dependent on the color-based detection only, and relationship between this visual aberrance and also elemental composition is remain unclear. Limited integration between online vision system and SR validation for industrial limestone classification, and we need more reliable and intelligent limestone prediction approach. Okay, so the objective of this project is first to analyze the relationship between the limestone visual characteristic and also the elemental compositions, and then to develop the MFIS, which is, I said, to integrate between the online vision system and also the MFIS system. And the third one is to validate the accuracy and also industrial applicability. So this is how we do it. Okay, first, we obtain the sample from the industry. So I mentioned just now, the industry we work with is in Ipoh, Perak, Malaysia. Okay, and then we obtain a sample, a lot of sample. Okay, and then we do the manual segregations or based on what the industry have given us. Okay, this is high brightness, this is regular, and also this is low. Okay, and then we do the sample preparation, crush, homogenize. Okay, they do the grinding process, and then we do the refill splitter to obtain the representative sample, and then we do the SRF analysis. And then we proceed to the modeling, okay, image acquisition and model training. Okay, there are two parts of this project, which is the first part, which I presented today, will be the image acquisition and model training. Okay, the MFIS is still doing it, okay, in the middle of it. So limestone image capture using LLM vision system, and then we do the machine learning model to train. Okay, and then there will be several parameters that we optimize. And then the last one will be the model validation and also evaluation. So in other words, that we predict based on 70% and 30%. So 70% of the sample, we use it for the training of the model, and 30%, which is the unseen by the model, we use it for the validation of the model. Okay, so this is all the samples that we obtain. Okay, the part of it. Okay, we divided it into several classification, okay, which is the HB is the high brightness, RB is the regular brightness, and LB is the low brightness. And Kinta B1, B2 is based on the several places. So if you can see, high brightness means that it is like very white in color, okay, but if we compare to the low brightness, it's very grayish. Okay, so this is the result for the SRF analysis. So I divided into three, okay, the relationship between the brightness and also the CAO content. So we found that the high brightness samples recorded the highest CAO content, of course, okay. So brighter limestone generally indicates a higher purity and lower brightness associated with the increased impurities. Okay, and then the relationship between the brightness and also the MgO content. So we found that the low brightness sample shows significant higher MgO and suggests dolomitic limestone presence, and high MgO may affect the industrial suitability. For example, in the cement processing, they want it to be in a very high purity CA content because it will affect the quality of the cement later. Okay, and then the relationship between the brightness and also SiO2 content. Higher SiO2 observed in the low brightness sample and indicate the mineral contamination effect, and some samples are sent for reject as a reject materials. Okay, so this is the model simulation. So we took 9,814 samples. So we divided into 70% and 30%. In 70%, we use for the model training. Okay, and then we have two sets of the optimization. Okay, set 1 and also set 2. And then from the 30% of the sample, we do it for the model evaluation. Okay. I don't know why we cannot get this. Just now we checked. It was okay. But it's okay. Compatibility issue. Compatibility issue. Oh, because I checked just now, it was okay, but it's okay. So this is the result for set 1 and set 2. Just now I mentioned that we use two sets of the model training. So set 1, it gives us the lower percentage, which is 88%, and the set 2 is like higher one, is 93%. So basically we want to say that the set 2 is higher optimized than the set 1. Okay, so this is for set 1. So if you can see, this is the predictions. So we can see that there are some predictions that we make that should end up in somewhere else, but it end up in regular high brightness. Obviously, the cross one. Okay. And then this is for the higher one. Okay, so we can see that most of them are being predict accurately. Okay, except for only 3 samples. Okay, so this is the code for the simulation. Okay, so this is for the video. So what we did is we tried to put it in the model. Okay, so it indicate the high brightness, for example. Okay, and this is the fail one, the inaccurate one. So if you put there, then it should give us, sorry, I guess this is the wrong video. Okay, so it gives here, it should be regular brightness here, but then it gives us a high percentage of the low brightness. Okay, so, okay, and then we have the simulation link. So we give the company the simulation link so they can directly use by using their phone or their computer. Okay, as conclusion, limestone visual characteristic shows noticeable correlation with elemental composition based on SRM validation. Okay, high brightness limestone sample generally recorded high CO content and lower MgO content, and also SiO2 content, indicating higher purity limestone. And the developed online vision classification model achieved up to 93% prediction model, which is the set to what I showed just now. And the finding demonstrate the potential of online vision system as rapid and also non-destructive preliminary limestone quality assessment tool. And current work is being extended, okay, towards the limestone, which we use the NV system just now by using MATLAB. And future work will also focus on implementing the developed prediction system or real-time conveyor belt platform for industrial limestone sorting application. So that's all from me. Thank you.
Unfortunately, we don't have time for the questions. We'll move to the next presenter.
Yeah, we have to move fast. Sorry for that. The next speaker is, and thank you for your presentation.
Thank you.
So, okay, the next speaker is Dr. Khan. Yeah, the next speaker is Dr. Stefan Muhammad. He earned PhD from University of Exeter, UK. His title of presentation is "Why is one core body not one core? Geometallurgy and AI in mind to plant control." Please, Dr. Khan, come and present.
Clearly. Hello, can you hear me?
Yes, we can hear. Mr. Khan, are you with us?
Yes. Can you hear me?
Yeah, we can hear you, and please present on this topic. Why is one core body not one core?
Yeah, can you share? Can you see my screen? I'm just confirming before I continue.
Yes, we can see.
Okay.
Thank you. Please go ahead.
Okay. So good afternoon. I'm going to present on why one ore body is not one ore, and what is geometallurgy and how it is being used in the plant control using AI models. So an overlook on the circular minerals economy and why it is driving us to think about more efficient processes and therefore look more into detail of how an ore body is interacting with the plant environment. And then I'm going to describe geometallurgy and some models with some conclusions. So we've been working for years on the linear economy approach, where the mine is considered as the raw material which feeds into the plant, and then we keep using the end products. But as we are progressing now into 21st century, so we are emphasizing more on the reusability, recycling, and that also stresses the need to make the mining more efficient, which will reduce waste, maximize recovery, save energy. And in doing so, we also increase the life of a mine by utilizing the raw material and the blending, the mixing appropriately. So those kind of emphasis on the making the mining more efficient drives us to look into more details of how a mining process actually works. So in this screen, if you look from right to left, so this is the plant is our end. So we need to analyze the profitability of a mine. It depends on the output of the plant, such as the recovery, which is the total metal recovered, the grade, and the throughput, which is the number of tons per hour. And they depends on the grinding energy. And in turn, it also depends on the material, the liberation, and the mineralogy. So if you see that on number 3, we have ore properties like rock strength, grindability, liberation, and the presence of deleterious elements, which behaves differently during processing, which kind of affects the grade and the recovery. And all of these depends on the number 4 geological indicators, which is lithology, alteration, and mineralization. And when we look into details into our ore body, so we have a significant variation in the lithology, alteration, and mineralization, which takes us to understand the ore body more. And those indicators or the properties that affect our processing is actually a geometallurgy, which is a new term introduced now into mining practice. And that's how we know about geometallurgy. the parameters or the properties of an ore body that affects the plant. Okay, so here's a porphyry copper deposit. So if you look at the copper deposit, we have different types of alterations like potassic alterations, sericitic alterations, and all those alterations have different properties. For example, potassic is normally hard. It has got high grade of copper, which is easy to float, easy to process, but very hard to grind. Similarly, primary hypogenic sulfide deposit needs fine grinding because the liberation size is smaller. So because the ore particles are locked into very small size. So all these properties kind of enables you can relate it to the previous slides. Why would this ore body behave differently in the plant environment? Because there are different types of alterations, different types of mineralizations occurring in the ore body. And so we have this field now, geometallurgy, where every deposit is it's pretty much now industrial standard of using geometallurgy as part of the resource estimation process. And what is geometallurgy? It basically characterizes domains within a deposit, considering their impact on the performance on the plant and output and the environmental and closure properties. So what we are trying to do in geometallurgy is to link the micro scale properties, which are the causes, to the effects it has on the plant, mineral processing plant. What are the properties important, like grade, mineralogy, texture, liberation? So what we do, we analyze the core into details, and then we classify the drill holes into different geological or geometallurgical domains. And then we combine those drill holes to a resource estimate model so that our plant can behave more stably and more statistically more stable and more viable, so that the production is can be predicted well. So this kind of explains the process that I just mentioned. So we take the alteration, mineralization, and lithological variations in the ore body, and there is a lot of machine learning and AI application in classifying those properties into different domains, which are geometallurgical domains that could have different properties. And each of these domains are then used to develop a resource estimate model. And when you're going to have a block model out of those, so you use only those drill holes which are part of that domain. So that gives us a very good estimate. It improves your estimates. It also helps your plant to be behaving more stably because you are anticipating based on your resource estimates. And that's what pretty much the industrial standards nowadays are. And it has then developed a lot of research as well. And since we have a lot of data now coming in from the drill holes, like logging data or mechanical properties, so a lot of research is making use of the mechanical properties to predict the domains, or the geochemical properties to predict the domains, or the effect of those domains are actually categorized based on their effect on the mineral processing plant. So as you can see, I'm presenting 3 case studies here. The case 1, making use of the statistical homogeneity of different drill hole geochemical data in order to classify them into different domains so that they can behave stably on the plant. Similarly, in the second part, there is geology, mineralogy, and metallurgy, which are linked to the mineralogical characteristic and the metallurgical performance of those variables on the plant. And in the third, we have rock strength properties that are linked to their behavior on the plant, and in turn we divide it into different domains. So these are some of the I've presented some brief literature in the background. Here in the Camborne School of Mines, I've been using to predict alteration units of a porphyry copper deposit from geochemical data. And what I've done is I have a lot of geochemical data available. So I've selected the geochemical data based on their different alterations. So for potassic alteration, I've taken potassium, sodium, and then some ratios, and I fed them into a model, which is a two-stage hierarchical clustering. So I apply PCA, kernel PCA, ICA, and then stage 1 classification with k-means and Gaussian mixture models. And then I evaluate it to get homogeneous domains so that I can classify them into different alteration zones. And what I saw was this is the true alteration that is being logged by the geologist, which I'm trying to predict. And these are my models from the independent component analysis and then k-means clustering and Gaussian mixture model, which produced a well-matching 75% accuracy. So as I said, most of the people are now trying to predict the domains or the alteration domains based on geochemical data. So this was one of the thing we did, and it's kind of so useful for the industry because we are moving on towards automation. So instead of relying on logging or physical logging by the geologists, we can save a lot of time if we can predict them using this way. Then moving on to the plant-aware scheduling. So once we know about geometallurgical's effect on the plant, there is also strong emphasis that we should learn the production schedule should be also based on the output of the plant. So for example, we have a lot of data being continuously generated from the processing plant, from the sensors. And this data reveals the plant response to different materials, and we can predict the throughput, grade, and recovery. And so that the plant can naturally update the extraction sequence of a mine. So nowadays, in a short-term scheduling, there is high emphasis that the production schedule should be also updated from the output of the plant so that we have a continuous production schedule output, which is called the short-term production scheduling. So here, this is a case study where a year of data has been recorded, year of block models and blending and the plant response. And we train that model. And then on the basis of that, we are able to predict where to what should be the production sequence and what should be the destination of a particular material to a particular mineral processing plant. So in this way, the plant outputs are coupled to the decisions that are being made on the mine in terms of extraction sequence and defining the destination and the blending strategies. So lastly, I've been working to develop a deep learning reinforcement learning for making such kind of plant-aware decisions for making a production schedule work. So this is a schematic workflow of that, which I'm not able to go into details, but I'm going to show you briefly what results we got from a case study. So the green bar shows the reinforcement learning, which also considers learns from the plant as well as considers the uncertainty of the geology, and it kind of matched well with the ground truth. And the reason for that was that because this reinforcement learning was able to learn the plant output, and in doing so, it was making better decision making for blending. And in the end, it increased the NPV by increasing the life of a mine. So if you have a more informed decisions from the plant, it shows that you can also have a better resource efficiency in increasing the life of a mine by 1 year. So in this case, this is a case study where we are still working on it. So to conclude, I've just outlined that one ore body is not all. We need to think about dividing the ore body into geometallurgical domains and how those domains are consistent for a plant output. So, for example, they can be needing different types of crushers, different types of grinding, and on the basis of that, you can make better decisions in the mineral processing plant during processing. And we just seen geometallurgy matters because it converts geological variability into better mine to plant decisions. So geometallurgy is the study of the properties that are ore body properties that are of significance to mineral processing plant. AI is being useful in mine planning and fleet management, but they are being done in separate pieces. And what I've been looking into here now to combine all those processes into one and apply reinforcement learning so that we can have a better resource output. And we just seen it gives a good results by increasing the life of a mine and increasing the NPV. And we need to have integrated uncertainty aware, because any model has to take into account the uncertainty associated with the mineral processing units or the ore body, or the uncertainty associated with your operations related to truck and shovels, maintenance, etc. And this mine to plant control contributes to mineral economy by increasing the efficiency of a mine. So we cannot recycle it in the mine, but we can make it more efficient so that our resources are more sustainable. So that concludes my presentation. And these are some references that I've used. Thank you very much.
Thank you for your presentation, Dr. Khan. It was a wonderful presentation. Or we call it geologist, and I understand you have covered exploration, you have covered mining, and you have covered processing. And all three are big challenges in any mineral project. Exploration, where you discussed the different type of alteration, because I conducted alteration mapping in field, as you discussed, argillic, phyllic, potassium. In porphyry, there are different types of alteration for different deposits, like scorn deposits, Mississippi Valley type deposits, porphyry, VMS, and you have concluded on processing. And thank you for your presentation. It was a wonderful presentation, and we will move ahead because we are in rush. We don't have time and we will move to next speaker. If do you have any quick question? Do you feel? Do you have any question? Can we move? Okay. We are moving toward
Problematic. The title of review actions, opportunities and challenges.
Getting slow down. You're not tapping with you by inviting the.
well, for that time is against us. That's the only.
It's by walking in.
It's a processing problem. Yeah, processing. You can go down, but you know.
Yeah, because it's gonna change it. Okay. Yeah, yeah, I'm just. I'm also switching to work from many minute was the did my leg. Here is gonna be my bigger. They will make it up. The WhatsApp. Right, there's a that was up number. That was up bigger. It's your surface and more things on the surface. I was very good project. Although work for many work. Just thank you very much for providing the opportunity to discuss my work. My presentation here is not very highly technical, but it's about what we are doing this to strengthen this sector in Pakistan and to create opportunities for people, for the students, and for the prosperity of the nation. So I will share with you what we are doing these days. And my professor is here, so Professor Khalisa, mashallah. He was my PG supervisor, and Professor Tahir Khan, and Professor Shukro. So I've learned from all these people, alhamdulillah. Bismillahirrahmanirrahim. So the presentation layout is mineral resources of Pakistan. Very briefly about the resources of Pakistan, and then I will discuss about the current efforts to strengthen the sector and some important ongoing projects. We are working on several projects, so I will briefly discuss about those projects. Okay, so from the mineral potential of Pakistan, a report which was published by government of Pakistan. This is about, these are about a few minerals like coal. It's around 186 billion tons, and copper and gold and silver and lead and zinc and manganese and chromite and iron ore. So we have large numbers of mineral resources. So several of our colleagues discussed these things in their previous lectures and discussions. So I will not discuss this in more detail. I will tell you what we are doing these days. In 2022, the government of Khyber Pakhtunkhwa made a working group for the mineral sector, and I was also part of that. That was very good group because that was based on triple helix model. There were professors from universities and from people from industry and from government. And we devised the Mineral Policy 2022 and a 10-year strategic plan for the government of Khyber Pakhtunkhwa. In the recommendations, I proposed two things. One was to establish a Khyber Pakhtunkhwa Mineral and Metallurgy Company. I proposed the name Mineral and Metallurgy Company. Later on, it was named as Khyber Pakhtunkhwa Mineral Development and Management Company. But this was registered with Security and Exchange Commission of Pakistan in 2024. And then in 2026, the board of directors was notified, and luckily I'm also member board of directors of that Khyber Pakhtunkhwa Mineral Company. In this company, we are trying to establish a mineral development fund, and it will be around 5 billion rupees for this year, because 45% of the revenue from the mineral department will go to this mineral development fund, and inshallah, if established, then we have some plans for that. I will discuss that with you. Like, for example, the second recommendation which I proposed to government of Khyber Pakhtunkhwa, that there should be a common facilitation center. What that common facilitation center, and then I presented this to Chief Minister Khyber Pakhtunkhwa, Ali Amin Gandapur, on 4th December 2024, and that concept was also approved by government. What was the common facilitation center? And I was the convener of this task force. Basically, everyone knows, and we were discussed with engineers, Yusuf Saab also, that we are replicating and duplicating things. There are many universities, there are many departments, and many of them have very good equipment, XRF and XRD and ICP and many equipment. And there are highly qualified people inside these universities. They are PhD people, they are very competent people. So there are very good, and the most important resource which we have in universities is not the equipment, it's not the building. I think these are faculty and these are students. And we can give them some task, you conduct a research work, and then that research work can be commercialized. Like I have, say for example, 40, 50 students with me. If in case I'm paying them, it will cost me a lot, but I'm paying them nothing. I just give them, my son, my daughter, you prepare this assignment, this task, and I will give you 10 marks. And for those 10 marks, they are working day and night and preparing the things. So its matter is not just that we don't have resources. We have a lot of resources, very top-class resources. Problem is that resources are not properly managed. The problem is the management of the resources. It's not that we don't have things. We have a lot of things. Problem is the management of resources. So I propose to government that there should be a triple helix model. There should be a combination connection between the universities. There should be a connection between the industries. You know, we are also teachers, we are also professors. And you know that professors don't like to go to industry. Industrialists don't like to go to university. So there is a big gap. So if we bring these people together, close to each other, then what will happen? Like, for example, my previous colleagues also discussed about the copper, about the chromite. Dr. Tahir Khan Sahab, he was also my supervisor at University of Calgary, and he talked about chromite. You know, we heard a huge quantity of chromite and very good quality of chromite, metallurgical grade chromite, chemical grade, different grades of chromite. And we can make different products from that. I have made several products from that. Just as Professor Tahir Khan said, that we just brought some chromite from Koistan, we just powdered it and just spread this, and that was comparable, the properties was comparable to that we purchased hundreds of thousands of rupees per kilogram of materials from United States and from other countries. But when we spread that, the properties were comparable. So what is this? We have resources. We have to utilize this properly. Okay. So I talked to So I talked to the government that these universities should be connected. And another thing, like for example, we are talking of copper. The price of copper, the payment which is made to government of Khyber Pakhtunkhwa per ton for metallic minerals is just 500 rupees. And if there is 2% of copper, 1% of copper, say for example, 1% of copper. So for 100 tons, this will be 50,000. But the price of copper is around 3.5 million rupees. So there's a big gap. And as Dr. Khan Muhammad said, that there is some oxide ore, and below that is sulfide ore. I'm not geologist. We are metallurgists. We know how to extract metal from ore. We don't know how this transformation happens. We're not expert in that. So this is a complete value chain. A geologist knows about the geology. A mining engineer knows how to extract metal from deposit. That is not my job. But as a metallurgist, that is my job to extract metal from that ore. So we said that, okay, another thing, like for example, so there is big gap, 50,000 and 3.5 million rupees. There is big gap. So if spend some money on students, spend some money on universities, spend some money on faculty. So is this something which we are losing or we are earning? We have very good, very qualified, very talented my students are here. And they're working very hard. So we have very good students, we have very good faculty, we have very good resources, proper management of these resources. Just connectivity is required, not more than this. Just connection is required. Okay. And then government support. So alhamdulillah, that Khyber Pakhtunkhwa Mineral Development Management Company is formed, and we are working, although slow, but still we are working. And then this Common Facilitation Center is also approved, and this is a part of this Khyber Pakhtunkhwa Mineral Development Management Company. So we will have faculty with us, we will have students with us, we will have industrialists with us, we will have government with us, and we will work together. And then, luckily, when you are working hard, so Allah Almighty Allah also create opportunities for you, for which you may have not thought. One day, I received a phone call from Higher Education Department that we are starting a project, establishment of Momentous Center at Fateh University, and you are part of that. I was in Chatral at that time, I came, and we started work on that. And now this is a 2.5 billion rupees project, and we were discussing the best thing which I consider, which is not available in any universities, at least in Pakistan. That is the pilot plants. I talked to the people, and I'm thankful to those people. They listened to me and they incorporated my recommendations. I said, you want scanning electron microscope. There are so many scanning electron microscopes. I don't say don't purchase this, but spend some money on projects. Spend some money on value addition, not only equipment. And then they incorporated 5 projects in that PC1. This is one about copper extraction. The other one is about directly reduced iron. The other one is about rare earth metals. The other one is about chromite. And the other one is about strategic metals. So hopefully we will include tungsten extraction in that project. So these are the things which we are doing. And then once we, from lab scale to pilot scale, and then from pilot scale, people say seeing is believing. I was running a project in Peshawar. There was upgradation of chromite. So when the system was running, the machine was running, people were coming to me and they were interested in investment. When supply of chromite was stopped from local Afghanistan, then no one came to me. When the project was closed, no one came to me and no one was interested in investment. So the purpose of establishment of these pilot plants is to demonstrate to the people, look, my professor is here. So extraction of copper from oxide ore, that is not very, like, for example, rocket science. That is not very difficult thing. That can be done very easily. You just show to people, yeah, this is what happens. And then people will invest. Because industrialist investors are interested in money. They're not interested in, say, for example, copper or chromite or these things. So you just show them, okay, the things, how it can be extracted, and then they will invest. So we are working in this model to go from lab to pilot scale and then bring investors and then present them. This is not PowerPoint presentation. This is the stone. This is its price, and this is the product which is made from it. And they will be convinced. They will be convinced. So this is the thing which we are doing. And then joint working group for minerals. We are member of that, engineer yourself. Yes. And there are people like, for example, and there is another thing. So we hope we will work through that platform also, and that is also a to make connectivity. Okay, yeah, Minerals and Material Research Consortium. This is just another initiative which we have started a few days before, and I'm thankful to Professor Fazal Khalid Saab, Rector GK Institute, Professor Tahir Khan, Vice Chancellor of Ahmedabad University, and Vice Chancellor of this Institute of Space Technology, and Butim, Vice Chancellor, and Pakistan Shole. These 6 organizations are establishing a consortium, inshallah, with the name Minerals and Material Research Consortium. This is just, we have started and we have discussed. The purpose of this consortium, yeah, this is not something which is new. This is not something which does not happen in the world. This is not something which is, I don't know what that is. This is happening in the world. So I'm sorry if the time is running very fast. So we want to connect our students, our faculties. GIK Institute is a big name. Very good teachers, very good faculty. FATA University is now developing, but FATA University has that facility. So if we connect faculty and students go to GIK Institute from FATA University, students go to Institute of Space Technology, faculty members deliver lectures, then that will be a great job. So that is what we are doing these days. Okay, and there are some ongoing projects which we are doing these days. One, Mr. Fang Ling also discussed this in detail, and we are their technology partners. We are working on liquid oxygen project, and this is Mr. Fang Ling knows about its mining and construction aspect. I, as a metallurgist, also know about its metallurgical aspects. If you use this liquid oxygen for the production of directly reduced iron using coal, that will enhance combustion mechanism, and the unburned particles will be reduced. that will result in a cleaner technology for the production of iron. And another thing which I want to discuss, a very big project in Pakistan was established. That was the Al-Tabarki steel mill in Karachi. In 2013, that started its work. But that was 1.26 million tons capacity plant. But that started work in 2013 and ended its work in 2013. That did not work. Huge investment. Why? Because the complexity of engineering problem was not properly addressed. Okay, so because I can speak.
Your time is about for
2 hours. About to all. Okay. Okay, so we are working with these projects. We are working on sponge iron project. We have established this pilot plant at Pakistan, and we are establishing a center, and these are the things we are doing this. Okay, so about liquid oxygen, Mr. Fang discussed in detail. So I don't want to discuss more about this. So as Dr. Khan Mohammed said, that there is copper on the top in the oxide form, and there is copper in the form of sulfide below that. We are interested in copper. We are not interested in whether it is sulfide or oxide. But the problem is that you cannot apply same technology to different materials. For oxide, your strategy will be different, and for sulfide, your strategy will be different. The oxide type of copper ore in Pakistan is about 20%, and the sulfide ore is about 80%. So we will extract copper from both oxide and sulfide. And a good thing is that copper can be easily extracted from oxide. So I have extracted it at my home, and 99.9% copper. So it doesn't require huge equipment and huge investment. It can be done. But for sulfide, it requires little longer process. Froth flotation, which will extract it, which will bring it to 25%, and then ESA smelt process is a very good process. It can bring it to 70%, up to 70%, and then after that there is a converter which can bring it to 90%, and then it can be done through electrowinning to 99.9%. So it's a long process, but that can also be done. So we are working on both the processes. So these are a few, like you can see. These are Torghar, Waziristan, Dir, Bajor, but I have visited around 10 districts where I have seen the different oxide ores, and in some places the sulfide ores as well. So these are the resources we have. So beautiful stones, but these stones of no worth if you will not make money from this. Okay, so we are. And this is the copper which I have made at my home. So and then I will refer another thing. Professor Khan today morning said that we coated chromite on some steel, mud steel substrate. And the property was comparable to a very expensive material which we purchased from the United States. Now, what is the benefit of knowledge? What is the benefit of knowledge? Same chromite can be converted into chrome plating. But this is a very long process. You will make sodium monochromate, then sodium dichromate, then chromic acid, and then chrome plating. I have produced all these things. And you just take chromite, powder it, and spray it, and you have the same properties. Another thing, when you come from chromite to sodium monochromate, chromite is trivalent, sodium monochromate is hexavalent. Hexavalent is highly carcinogenic. So this is another issue. So if you make chromite coating, just high elasticity fuel coating, you will get very good properties and without such transformation and very easy. Okay. So thank you very much. There are so many things, but
Thank you very much. Oh, I'm happy, now that you make a mention that we have a lot of resources. We have intelligent people,
Yes.
intelligent students, professors.
Yeah.
But the whole day, people have been talking that we don't have anybody in this country who knows mining, especially Mr. Hassan.
Yeah.
So it's a good topic at the end of the day. We know that we have a lot of mining engineers, electrical engineers.
I would like to add one point. You have shown us beautiful malachite, chalcopyrite, bornite. These were copper ores.
Yes.
Green, blue.
Yes, yes. Yeah. So basically, I'm not a rich man, I'm poor man. I want to start with the limited resources.
So, friends, for tomorrow, tomorrow is session. So, well, you're a doctor. No, it's not, we are learning. It's not, so we have. So we have the last speaker of the day, Mr. Momentous, Seven and their province, neurological engineering complex of Pakistan branch.
Okay, so I'm trying to keep this speech short, and I think everybody have a great day now. First of all, it's been a great honor to be able to speak here, and also, unfortunately, my CEO is not able to come here today. So I'm basically just going to brief through this presentation by myself. So let's get started by introducing my company. So my company name that is the District and Geological Brigade of Sichuan. It's a government institution company and belong to the China government of Sichuan province. And it's a comprehensive geological exploration unit under the Geological Bureau of China Sichuan province. It's been formed in 2023 through the integration of the three distinguished geological teams. And our earliest predecessor actually started from year 1960. So over the last 60 years, we have built a strong reputation in mineral exploration, especially in phosphate, exclusively in our company, and the chemical mineral, and have been recognized as the national model geological exploration and unit. And since 2015, my company have continuously followed the participation in KP province and the mineral resources. We have established our permanent office in Pakistan, and we have conducted long-term research on the metallic belt and the mining policies in Khyber Pakhtunkhwa. After 10 years of deep engagement, we strongly feel that KP is a rich in mineral resource and huge potential. And so we're going to break down our speech in different topics. So first of all is our review, our observation on KP's mineral resources. And KP is located in the Western Himalaya tectonic belt with excellent metallic condition. It is one of the largest and most resource-rich province, and the advantage mineral can be grouped into 5 categories. The first one is the metallic mineral. There are 9 key metallic mineral blocks covering over 1,445 square kilometer, and many in the Chitral and the Hazara belts. Representative minerals include copper, gold, lead zinc, nickel, and platinum group elements, as well as coal mine. The second thing that is industrial non-metallic mineral. And one of the key material that is phosphate, and we think that is the most strategic material. Phosphate rock is mainly distributed in the Hazara region, with a proven reserve of about 36 million tons, and prospectively resource up to 200 million tons. The Magarban deposit has an average grade of 28.5 degree. The very high quality resources, and the phosphate is a key raw material for fertilizer, and directly related to the food security of more than 200 million people in Pakistan. So it's so important, which cannot be overstated. In addition, and we also have a material like rock salt and limestone, silica sand, and other things that will. And let's just bring one example. In 1985, Pakistan had invested 10 million USD in Kakul phosphate project, but eventually have been failed because the factory over there and the technology is not able to remove those radioactive impurity and the cadmium. And this case shows exactly the core bottleneck for the phosphate industrialization and the beneficiation and the impurity removal. And this is precisely the area where our company has decades of experience, so which we can put our effort in and hopefully to achieve something in future, along with our government, with the Pakistan government. The third, that is the gemstone. We all know that the Swat emerald is the world famous, and also the pink copal is also a rare variety, along with other materials like ruby, sapphire, and peridot. And the fourth category, that is the dimension stone. And I personally have this experience in the David for the granite, and also you have the great marble over the KP and different products as well. And fifth, the energy minerals. The natural gas is estimated around the 16 trillion cubic feet, and oil at about 1.1 billion barrels, mainly in Karak and Kohat. Oil and gas exploration have a success rate of 1 to 3, and far above the global average of 1 to 10, representing a low risk opportunity. And also coal resources in the southern and the southwestern part also have a great potential. And the current status of the current challenge in the mining sector of Pakistan. At present, the overall level of the mining development in the Khyber Pakhtunkhwa is relatively low. The marble and granite are being mined, but the annual output only about 145 USD, a million USD. Blasting leads to no recovery and insufficient processing, and phosphate is almost idle. In 2020, private mining produced only 5,100 tons, and there is no commercial beneficiation plant, just everything go with raw material. And gemstone are mostly exported as rough stone. The top mineral also still at the exploration stage. Nothing we can see is in the industrial mining in scale. And only limestone now have been excavated and also supplied to what we know cement factory, and oil gas and operated by international companies now. So it is worth to noting that Pakistan import about 1.8 million tons of the phosphate rock every year. And in 2023, phosphate acid import alone costed 306 million USD. And so we have also lost a lot of the foreign exchange. While KP's high quality phosphate rock remains untapped, it's not being utilized at all. And on the policy front, the KP government has attached great importance to mining development in recent years. We have seen those things are happening. The first provincial mining policy was issued in 2014, and the Mining Revolution Plan was launched in May 2024. New Mining and Mineral Bill was reviewed in April 2025. And in January 2026, the provincial cabinet approved the establishment of the Provincial Mineral Resource Development, like we have been introduced before, and a management company, with 45% of mining revenue to be channeled into mining development fund. The improving policy environment created favorable conditions for Pakistan-China Mining Corporation. However, the major challenges remain: the outdated mining technology, weak infrastructure, illegal mining, serious shortage of the processing capacity, and insufficient capital, and the policy implementation gaps as well. We'll come to the number 3, the core competency of our company, so what we can do. First of all, remarkable exploration achievement. Since our company's establishment, our brigade has discovered a total resource of more than 6.5 billion tons, covering over 20 minerals, including sulfur, phosphate, mineralized coal, gold, copper, zinc, rare earths, and uranium as well. In the field of phosphate, to be specific, we discovered 3 large high-grade phosphate deposits, laying the foundation for China's phosphate chemical industry. We are recognized as the founder and leader of phosphate exploration in China, we have also discovered more than 10 million large new type of uranium deposits and made a major breakthrough in lithium and potassium resources. Second, we have a full technical chain from exploration to industrialization. Because some companies, they only focus on exploration, but to our company, we have this experience from exploration to final industrialization, this whole chain of those lines. This is a rare advantage among Chinese geological brigades. We not only find mineral, but also process and industrialize them. We have 7 research platform, 9 core technical team, and a state-certified laboratory capable of full element analysis, mineralogical studies, beneficiation testing, and impurity removal. We can provide one-stop solution for the resource evaluation to produce scheme and economical assessment. And also, take example of phosphate, we have achieved the closed loop, discover a mine, active a chain, and drive an industry. That's what we can provide to Pakistan. Third, the long-term presence in Pakistan. Not like any other Chinese company, they normally come and go back. We already been working here for the last 10 years. That means we believe we also be the only one Chinese state-owned brigade, geological brigade operating in China, in Pakistan. In 2017, we have established one subsidiary company and one commercial representative officer of Sichuan province in Pakistan. Up to now, the second geological brigade of Sichuan is the only one who maintain a permanent office in Pakistan. So we have continuously provided mining technique consulting and project evaluation service to KP. But before we're more engaging with the Chinese state-owned company like China Cedar and other Chinese companies who is interested in the mining sector. But now we decide to stretch our hands out to cope with the Pakistan government and the Pakistan local company as well. And fourth, the strong institutional strengths. And our brigade has more than 1,000 employees, nearly 50 of them with bachelor degree or higher, nearly 200 senior or professional senior titles, 48 qualification certificates. That means through our company, actually you have access to many, over 100 brigade resources of the potential engineer and all kinds of laboratory. So exploration and the phosphorus resource utilization together with the Hydro-Power University and the Mineral Development Department. And on the Chinese side, our company will take the lead. On the Pakistan side, we'll lead on the technology side. On the Pakistan side, we will invite all the company and the Pakistan government, the KP government. KP is the Mineral Development Department, UAT Peshawar, University of Peshawar, and also Geological Survey of Pakistan to cooperate together and to have the scheme how to going to develop the mining sector in future. And our priority research directive, first of phosphate, beneficiation and impurity removal. So we already have this exclusive target, which we plan to do in future. And second step, that is we're going to have a metallic regularity and exploration technology for advantage minerals. Third is the phosphate fertilizer and the phosphate chemical product development. And the fourth is the mining environmental monitoring and ecological restoration. Because mining can also consider the environmental impact. I think we have long experience how to restore the environment as well. And how to implement this plan. And our path that is start with our CMA certified laboratory and technical support. We're ready to shift our whole laboratory into Pakistan and set up a joint workstation in Peshawar linked with the existing platform. That means this platform has been created by government, either by the institution or the government. And gradually upgrade into physical joint laboratory, which will combine the university laboratory with our local expert level. And the Pakistan partner university and research will also directly participate in joint research and development, share the experimental data, receiving training, and have priority hiring for locally trained talent. And coming to the next plan is how we are going to have our vision in future in mining development in Khyber Pakhtunkhwa. And overall recommendation, we're going to process a 3-in-1 cooperation model. That means the joint laboratory as the research and development.
You're running out of time.
Okay. Okay, let me come to the conclusion. So basically, we have the willingness to shift our effort to blockchain through the network cooperation. We like to get to know the blockchain company and also the minority sector and cooperate with government to develop new policies. And from the phosphate, we're going to introduce our technology and all access to capital and investment to build this industrialized phosphate in blockchain. So from this one specific material to develop in the other material as well. Thank you. Thank you. By the way, in the end, I'm not technical person, so if you have any question, I will share my contacts from Mr. Fraz, and feel free to ask any kind of question. I'm willing to reply all of it. Thank you.
We have district book certificate deals. While we do that, I have two announcements for tomorrow. Number one, we need to start here at 9. So, no other request to be at before 9, please. And then after the session, we need to go for the ID. ID, we have ID. Dr. Suku, please come and receive your. Next is Mr. Franklin. Please come over and receive your certificate. Come forward. Thank you. Next is Dr. Q. Istrahani. Most welcome. Dr. Abdul Batin. Mr. Mayo. So let me have the honor of presenting this. Thank you. Oh, what is the bus? Thank you. So our speakers also have requested that they should also come and attend the session. And all the participants are requested to be here before 9. Thank you. And now you are requested to stand for the height.
Thank you so much. Razal Ande.